Okay, you hear me now? Looks like it. Does everybody hear me? Hey! Okay. Right, so by popular and annoying demand, we're going to have a look at CSpect. So here you can see the project. As you can see, it's not small. There's a fair amount to it now. Some of these things aren't used yet. They're things I want to try and do. But for the most part, it's all kind of used. Right, so going through. Alexa, volume down. Sorry, it's a wee bit loud this side. I'm sorry if I've just annoyed your Alexa devices. Okay, so programs comes in here, initializes, finds out where we are, and then starts to do actual work of setting things up, RAM banks, positions, usual kind of things. This is all to do with the plugin system, read-write stuff. Basically every operation pretty much, it'll try and detect if there's a plugin for it. So it does take a little bit of a hit performance-wise for these things, but the plugins are one of these things that are just so useful, it's worth taking that hit. It just goes to initializes a whole lot of things. There's two different ways. There's one that's the kind of main initialization, and then if you hit F3 and do resets, it doesn't reset this kind of stuff. And then it parses the command line, which is quite big and ugly these days. So this is just extracting stuff from the command line. There's nothing particularly exciting with that. It's as you'd expect. Hey Jim. Lots and lots of options. Lots and lots of options. Some more complicated, like filling memory. You do have the option to fill with random stuff or fill with byte sequences and patterns, mainly for some of the next guys that wanted to do testing stuff to see what happened. Shader stuff. And then some of the newer bits, which is we now check. We try and look at the file that comes in to see if it's an SD card or if it's an X file or something like that, so that we can auto detect some of the command lines just to make it easier to start up. If it's an SD card, then we set up basically all the command lines needed for that. Send some analytics so we can keep track of that. I haven't checked them in a while, should really go and check them. OpenAL, that's our audio system. We try and initialize. We also do a bit of detection to see if if it's actually installed, and then tell you to go and install it. We've got the serial port, which we have a whole thing for, which is done through an interface. Mainly so we can plug in other ones if we wanted to. I don't have anything at the moment that changes it, but we could in theory. So again, it does pretty much what you expect. Initializes the C# serial port. Then it's got the different commands that get passed down from the Z80 for reading and writing the hardware serial that you can plug in. There's nothing particularly exciting or complicated with that. Two. We've got our symbols, so if you provide a map file, it will go and load the map file. There is now two different map files. There's a new one coming that is for source level debugging, and it's broken up. It's kind of any file-esque in that it's got sections. If it doesn't have one of them, then it uses the old format. This is actually mainly C code conversions, so it's a bit long and bloated because it was just copied over when we moved from the C into C#. It's very long. The newer stuff's much shorter. We also have the source files, so they get added in for source level debugging. There's still a ways to go on that. It's not ideal. I think I would like it. It's kind of hardwired at the moment to be assembler. So you step in, as you do now, through assembler, and then it tries to match that to your source file. Really what I think I want is to step in the source file, so it looks at the next line in the source and puts breakpoints and stuff or traces to them. That way you could start using it for C coding, and you could just output the lines for C. It would make a bit more sense for that, which would be quite nice. So anyway, so that's the symbol table stuff. It then starts up the renderer, which is just OpenGL with OpenTK. Starts doing gamepad stuff. The debugger screen is just another texture that gets drawn over the top. If you've got the shader enabled, it will load that. I don't know how many people actually switch that on these days. I do want to move the mouse into a plugin so that folk can fix them if it's a bit poop. Like on the Mac and Linux just now, it's not great. And then yeah, so 50-60 Hertz, VSync, all that kind of stuff from the options. If audio was enabled, you start that. The audio system, I'll have a quick look in a wee bit. That's basically just a streaming system. We also try and detect if there's a new version out, which is basically there's a little file on the net and it goes and downloads it and compares them. And then just tells you there's a new version available. So, so this is the main loop, which isn't very complicated. So it will basically process a frame and then use OpenGL to draw it. So there's two methods of processing. One when sound's active, so it can tie the loop to sound ticks, and one when sound isn't active, where it just ties it to the rendering text. That's why you can't have smooth scrolling really when you've got audio on, because it's having to tie it to the audio, and audio and video don't sync up perfectly. So it's got to be one or the other. There are some ways that are quite complicated of stretching your audio out to fit whatever your frame is, and it basically stretches it bigger one frame and smaller the next and adjusts it. It's a bit of a faff. So the main loop is just waits until there's audio, fills an audio buffer with whatever the Z80 generated in terms of audio, pumps that off as another buffer for the next frame of audio to play, and then draws stuff, and that's it. It's not complicated. Process main is the main processing of the emulation, where it does a single frame. Now, because we are scanline based, hey Flash, how you doing? Because we're scanline based, we basically process a line, draw a line, process a line, draw a line. So it's pretty simple. but it is the kind of fastest and simplest way of doing it. So if we're in the debugger, it does this. This is why the debugger doesn't really track vertical blank and raster lines terribly well when you're stepping. And it's why when you do breakpoints and stuff, it'll tend to go straight into, or run until, it'll tend to jump straight into like an interrupt or something. Because it's not really doing a single tick within that bigger loop. Has to be said, if you're doing it on a real machine, you'd have the same thing. You know, the machine's ticking away and you're debugging on that. It's going to get the same kind of thing. Greetings from Germany. Okay, we're going international. So in the normal loop, when you're not in the debugger, we first checked for to see if there's a VBlank interrupt, and then it goes to our Z80 module, tells it's a ULA one, and triggers, and it will return the number of T-states that took. And we've basically got this local T-state counter that counts up, and we use that to compare for each line as we go. So we also got plugin manager. Every plugin can get a tick once a frame for doing stuff, and that's, again, we'll go through the plugin later. But you can kind of do anything you want at that point, and be guaranteed that once a frame call. That also happens in the debug stuff, so you still kind of get them. We do have the special remote debugging as well. The DZOG plugin stuff here, it uses that. You can do a full debugger yourself. And you'll notice down here I did start doing a debugger as a plugin, so you had an actual window up, which I would still like to do at some point, because I think it'd be easier having a Windows Forums debugger that's open source that people can kind of add into if they wanted to. So that's a longer term goal. So let's get down to our main loop. Now this is per scan line, and this is basically just instructions. Norwich. That's not quite as international Flash. The dumplet is Norwich. So while we're processing individual instructions, we've got our history recording, so you can rewind, and this just tracks everything if it's enabled. It is a bit slower, but it can be invaluable when you get these funny crashes and you just want to rewind. So let's start recording just starts a new store. So this is the history store, and it just tracks all the registers, all the different RAM banks, and all the kind of major things going on, spike tuning and all this kind of stuff. So if anything changes, we've got separate checks inside peek, poke, in, out to monitor memory changes, so we don't have to dump the whole of memory. And then when we come to rewind, we undo these changes. So if something was poked into memory, we'll remember the old one, and then that can be poked back in again. So there's a restore. It just goes back through setting everything. And then for each chunk, we kind of look to see what it is and where it came from, and we will put that value back in. So it's a bit of a faff, and it's certainly not 100% at the moment. But you know, if you're needing that little bit of extra, you know, what the hell happened there, you can switch this on and kind of rewind, which is useful. So remember the last T states, and we check breakpoints. We've basically got an array of the whole of memory, and we check to see if that's true. That's just a big, you know, byte field to go 0, 1. This was another C thing that was just bytes rather than bools or something. And then if it's a breakpoint, we'll flag it to go into the debugger. Stick here. We also look into the physical breakpoints, because remember we've got several kinds of breakpoints. So the physical breakpoint is the one that's in full 24-bit memory, and it gets the bank, decodes it, finds out where it is, and then it looks at this array, which is just a 2 meg array, which has again got a flag set to go. There's a breakpoint here, in which case it goes into debugger. If it goes into debugger, then it starts going into here, and it's debugger and just returns, doesn't do anything. So if we're not in the debugger, then we start looking at the raster line stuff to see if we want to throw raster interrupts. Now you've also got to adjust it for the scan lines. Although my drawing starts 32 scan lines above where the screen is, the next 0 scan line is actually the top of the screen, not the border. So you've got to adjust that. You've also then got the raster offset thing that it's an X register that just subtracts off again as well. So you've got various calculations to find out the raster line you're actually on. Then you compare that to the raster IRQ one, whether it's on, whether it's already been thrown. If all that's satisfied, then you start going, okay, is IRQs on? Then you start setting them, and then you go into the kind of throw the different IRQs. I don't think it actually throws it here. I'm not seeing an actual throw, I think it just sets. Oh, there we go. I know which one it is. Now the interrupts are far more complicated these days. So this is the normal part. So IM zeros. But you've also now got all the vector interrupts to deal with inside interrupts. And at the end of the day, it still comes down to push the PC, set that, blah blah. But you've got the different where the vector comes from. Alan did tell me this 19 T's to get into an interrupt. That wasn't quite working for me. My timings certainly aren't precise, so I do adjust a little bit to try and make it fit better. So, all this kind of stuff does go, yeah, you've also got stacked interrupts, and when you throw interrupts, it does a whole load of stuff. Interrupts on the Next are pretty complicated these days. Yeah. It's not just a straightforward 2 interrupts that we used to have. They're quite complicated. So anyway, that's all the interrupt stuff. If it's not throwing, then on we go. I did think I had a scan line when it threw. Maybe those ones don't do it. Right, so on to execute a tick. Now, we've got the copper and DMA that basically run at 28 megahertz all the time. So let's have a look at the copper first. We've got a whole heap of stuff up here to do with that. So, various copper things. It's the copper memory, current addresses for putting stuff in, partial writes because you kind of write it in 2 halves, and so on. So, different copper modes, poking about into memory. Excuse me. Peek poke is written. Now, this was for folk that were running copper stuff where it wasn't being initialized. So this threw up an error so you knew when you were debugging stuff. This comes back to it being a dev tool really rather than an emulator. So this would tell you you're trying to run copper that isn't initialized. So it's just a flag to go, this has been written to at least once. So the copper itself, it's not terribly complicated. It's basically a wait or a store. The big thing is it's got to run over a number of t-states. And depending on the speed it's going, that number of t-states is kind of scaled. So if you're at 3.5 megahertz, then we've got 8 times the number of t-states to waste as it comes in. So the copper does run at proper speed, and the stores do happen approximately the right point along the line. Because we are not cycle exact in that if you execute a command like load from memory, load A from HL something. Now that'll take set number of t-states, is it like 12 or something? But they won't happen in the memory read-write order. So really what you should have is when the opcode's read, that'll take 4 t-states. When memory's accessed, that might take another 4 or 8 t-states, and so on. So all these things progress in 4 t-state steps. And then really the copper should move along each time in 4 t-state steps at that point as well. However, because the emulation is just execute that command, return 12 t-states, we have to run this as do 12 all in one. So it'll kind of go in jumps to catch up with the CPU. So there's minor differences in that, but it does go along the scan line going store at this, you know, we've hit this vertical and horizontal position in the scan line, do stores. So the V weights and H weights should all work properly-ish. Never be exact, but it's should be close enough. If you're trying to draw a picture across the way, and if for some reason I ever did that to actually generate a background image based on copper stuff, it would still be approximate, and it would give you roughly the right thing, but it would never be perfect. But it's not like the copper waits until the end of the line and just executes a line. It does do it as it goes across the screen, just to keep track. Because one day it would be nice to do some background tracking for rendering, so that you could draw into the background color and do things. If I ever get bored and I want to try that. However, so we get a number of t-states that have been executed from the last thing. We find out the lines that we're working to for doing the horizontal and vertical weights, and then check the mode and everything that's running in, and then we basically burn and do this stuff for that number of t-states. So 2 t-states each time per pixel, I think it is. 2 t-states per pixel, I think. So it basically just loops around here, keeps checking the raster, moving along. As copper's t-state count by number of scan lines just figures out where it is horizontally, and then when it does get to that point, it can move to the next instruction, then does the actual store, then moves to the next instruction, so that's obviously the next set register, and then moves to the next instruction, and then just keeps looping for that number of t-states. Right, so that's the copper. So if you execute a Z80 command before, because this is the previous one really, it's doing coming in here, or vblanks or something like that, then it will execute those t-states. The DMA then does exactly the same thing. It plays catch up to where it should be. Now, DMA is also reasonably complicated. So there's a whole lot of like modes in the mini program test up there for different registers. So you can see it kind of loads from registers, and it's got your different write controls. And they're all partials as well, so you write to these things several times to get different things. And then depending on control bytes going in, it does different things. So it's all the sequencing that it takes. So it's a bit of a faff, to say the least. All comes in through a single thing and then goes out to whatever it's currently writing. And then your reads. The reads aren't right. There are issues with them. when things trigger. So the tick is exactly the same, the number of t-states. It's got the scalars. Not sure why that's dividing the number by 2. I think it's 4 t-states per byte or something it does. It's been a while since I've done this. I can't remember. 4 t-states, 4 cycles. Okay. So from this point on, it's really just doing the actual kind of render loop, load stores of things. It's not terribly complicated. Also noticing it's not doing a while loop there at all. Yes. I think that was on my to-do list, but I never got around to doing it. This should be doing the number of t-states, but it's not. Yeah. Not got around to doing that yet. So, in general, it's going to be quite close, but it's not going to be exact. Again, if you're using lots of t's up in big instructions, it should be looping around, burning them all up, but it's not. So the DMA will be out. Oh, interestingly, I think our DMA is faster than the next one. So I'll have to look at that and see. Okay, that aside, it's supposed to execute for the number of instructions, gets the number of ticks that it's done, because it can be blocking, so that would add on obviously to the number of Z80 ticks that it's got to do, or adds up for the number per line that it's doing. I wonder if that's, I might use this loop to actually do the DMA. If it's not done yet, then it won't actually execute another instruction. So I'll just spin around here. It's been a while since I've done all this stuff. So the general idea is the copper executes for the number of t-states, so does the DMA. It then executes an actual Z80 instruction, gets a new local length, and then that's the instruction length. I'll do the Z80 stuff in a wee bit. It then uses that timer as, that instruction length as the number of ticks to pass into the timers, because they also execute at 28 megahertz. And then it does sit over 28 megahertz and it spins around all the timers. So the timers, again, have a funny calculation value. I think we've got, was it 4 timers at the moment, but there will be 8, but it's been cut down to 4 just now. It's just arrays of these things. It's got the different edges and types. Sets the values depending on what you're doing. For the different counters. When it comes to tick, it's got to loop through every single thing. So every single timer, every single t-state, it's got to loop through. So timers are very expensive to process. I have tried to do them as best I can in terms of performance, but there's just sometimes you just need to do it for it to be remotely correct. You also have the cascading timers, which when one ends another one starts, and timer can throw interrupts. So like I say, if you've got a big instruction or lots of DMA or something happened, and it's got to loop around every timer for every t-state, it's not like you can subtract off certain numbers of t-states from the timers because of all the cascading stuff. It gets very messy. Hey Magnus. And you've got the different interrupt types. And that goes through the throw interrupt. If you remember, that's this big one. It's got all the different types of interrupt that can also be stacked if one goes off and other ones are waiting. So this is pretty nasty in terms of if you've got lots of T-states waiting, it'll sit in that loop for a while, which is yucky. And raster T-state counter. So we've got a certain number of T-states per scan line. So all these add up together, and then when we're above halfway, I think this is for the audio. Yep. So when we're over half a scan line, we do an audio tick. So the audio is at 600 and something. So it's 312 times 2 times 50. Oops. So 31 kilohertz audio is what we use, which is basically 2 ticks per scan line. So over halfway, we do the first tick, and then at the end we do the second tick. Now we come to the draw a line, which is there's the screen kind of broken down. We try and draw when we're past this. That's the theory. So that we have things that were set up in this border. So instead of drawing at the end for the next line, we try and draw here so that this stuff's been set up. Again, because it's not precise, it's not going to be perfect, but it's what we do. We flag it's been drawn, and then we draw a scan line. We'll get into the draw later. That is not pretty. What's that one for? I can't remember what that's for. I think that's just detection for something going wrong, but I can't remember. It might be recording stuff. A lot of stuff in here that I put in that was just so long ago now. I think I started doing this emulator about 5 years ago now, and it's just slowly evolved, so it's hard to guess what a lot of these things are. Yeah, I can't remember. I have to go through it quicker. And then you've got the recording. So that's done one extra. All this is basically one Z80 instruction being executed. So when you get up to 28 megahertz, there's quite a lot going on now for it. It is quite busy. If it gets to the end of the list and the drawing hasn't been drawn, then we'll draw it anyway. So if we hit a halt or something that stops all this processing going on, or for some reason it didn't hit this for some reason, say it was a big DMA thing or something going on that just overran it, then it will still draw. It won't leave blank lines, and we'll move on to the next raster. So from there all the way up to here, this is a single instruction. We do this every instruction, with things like the timers taking up, lots of ticks within that as well. So I'm amazed it runs the speed it does. I have to be certain. It's very slow. I do have some debug code in here if I ever want to record the audio, just a massive buffer that I can then, raw buffer that I can then put into a wave or something, and I can do that. After all that, then we can take a screenshot that's basically the screens get, the textures get rendered out rather than grabbing the screen. So you get a slightly nicer screenshot. The draw messages, when you press things like F10 and you get little messages coming up, that's for those things. And then there's some of the debug stuff for drawing the thing over the top. Right, so the Z80 itself is probably the simplest part of it, and it's very old. The core of this was done, geez, when did I do this? Late 90s. can see. And it's changed a lot since then, but it's fundamentally still the same thing. And it's the basics of it is comes in. You'll notice we've got plugin stuff for every instruction as well. So remember all this stuff on the outer loop that does all this thing for every instruction. It then has several plugin loops and checks for every instruction, every memory write, and all that kind of stuff. So it's doing a lot. So that's executing. If you've asked for executing memory thing, then you'll get a callback at that point. And we've got our new headache, which is the auto memory mapping, which again, every instruction, it's got to do a whole heap of ifs and buts. So if things are paged in, if addresses within range, then you've got to trigger the div stuff to be paged in and ROMs to be paged in. Again, this isn't pretty. It's got to go through all these ifs and buts every time. That does take a significant hit, which is why you can disable it if you want to. So just running a next from a command line, you don't really need it. You can switch it off to get a little bit of speed boost because we are starting to notice some of the performance. So we get the next byte of memory from for the PC, which is you get the PC. Again, these were all accessors, which I've never really gotten right to changing. These days I would just make them ints, get rid of the function calls. C# will tend to inline all these. It is handy occasionally being able to put stuff in just to check, but I should just make them ints, and then if I get stuck I can make it a property. I might get around to doing that at some point. That would clean up this code a fair bit. So that's getting a bit of memory, that's getting the address, and then we peak memory, and then it gets even more complicated. So we've got read-write breakpoints that we have to check. If you're in a certain turbo mode, there are extra T states added. We slowed down the 20 megahertz a little bit, so that kind of slows that down. You've got plugins for every memory access as well, which is just like all the other stuff, if there's anything. So the plugins are, there's again a massive array of, I think 64K array for plugins. So it does mean that if there's nothing in there, it can just skip over it. And you can have multiple plugins for each address. So if somebody's written a plugin that looks at address 4000 hex, somebody else has a plugin that looks for that, they will both be called. If one of them handles it, then the other one won't get called. But one of them just monitoring and then the other one handles it, then it will run both. And it does this for every memory. The first thing we check is if it's, next, ROM, RAM, paged in. So if it's not next, so that's basically just Spectrum emulation. Under that you get Spectrum ROM returns. If not, then it gets very complicated. Everything's broken into pages, so we've got to check. First page, we've got multi-face. This is the priority order of how memory is paged. Div MMC stuff. Layer 2 banking in, which point you start getting layer 2 bank. Yeah. If the layer 2 is banked in, does all that. If the RAM bank is, so this is the MMU stuff. If it's not been paged in the lower 3 bytes, in the lower 2 banks, then it goes into the ROMs, so it looks at the alt ROM. You have write mode. Otherwise, it starts coming out some of the other ones. If after all that, it's not, then it goes to The next ROM, yeah, based on the ROM, because there's a whole load of memory space in there, so based on the ROM that's been paged in, it will then access that plus the address of. If there has been stuff paged in, then this is 2 meg of RAM. It'll get the bank plus the address and then return that. And that's for anything below 2000. Anything below 4000 to 2000, it does all the same thing again, but with different bankings and then different offsets for things. And then again goes to exactly the same thing, and this time it's got another RAM bank. So again, this is everything. Every time you read a byte from memory, it's got to go through all this. Then if layer 2 is mapped to the lower 48K, so there's that special mode where you can just have the whole of layer 2 mapped in, and that's at the lowest priority. Then it can go through and get that from the layer 2 bankings. If it's not done any of that, so it's over 4K to 8K, so this is in the contended memory, and memory T states are on, because you can disable them in the next registers, excuse me, then it will look up the delays. Now the delays are based on T states, so it's basically that over and over again. So if you imagine the scan line in T states going across, if you on T state 4, 2, 3, 4, then this would be added to your T states. You know, if you're on T state 0, that would be added, and so on right across the line. Now again, mine isn't exact because I do bulk adding of T states to a command. So that LDH, LDA bracket AH, it takes 12 cycles. I add 12 at the end. Really, again, I should peak a byte of memory, add 4 T states, get another byte of memory, add another 4 T states, and so on. And then those local T state frame delays would be far more accurate. But because I do it at the end, I basically get a delay at the start and then a delay right at the end of it, which is just, it's wrong. But changing it would mean changing the whole Z80 to do proper read-write access for everything. I don't think that would really slow it down, but it's a massive undertaking to go and do for very little gain, because it's really only 40K spectrums that kind of do that. And I mean, this is an Next emulator rather than a Spectrum emulator, a 40K emulator. There are loads of 40K emulators out there that do this kind of stuff, so it's less of a concern. It's just, it gives you a little bit of a feedback for it. It's also leftover from when this was only a 40K emulator. So if it's within there, it adds T states. Other than that, it basically looks up the bank that's you're peaking, adds on the offset, you know, so that's just the address handed off. That's the offset and the address shifted down, so it gets the bank in 8K chunks, and then returns that memory. And that's peak. So every byte it gets has to go through all this, you know, which is fairly hefty. You can imagine poke, which we'll just do just now, exactly the same thing. So you've got write breakpoints, you've got your local T states, you've got your plugins, and then exactly the same again. You know, if you try and write in these things, you're not going to be able to because they're ROM, if they're paged in. You do have the recording stuff as well that tries to record what you're doing here. So every time you actually manage to get into poke a byte in memory, then if the recording's active, then we add this address changed, and it keeps a big list of them. So if somehow you were doing something that changed 2 or 3 bytes of memory in one go, then it would remember that. So storing HL into memory, because it's a single instruction and we do them in banks, then that recorded thing would be executed twice and there'd be 2 elements in there for that single state. The tile stuff we have special stuff for, because we don't, to keep up the rendering speed, which again we'll come to the rendering, it's probably one of the most expensive things that we do. We don't want to have to decode from memory every time we render, because it's incredibly expensive. You know, you have to shift things around and do, you know, for single color stuff. If we had to do this for every single scan line of every tile, you know, would take a massive hit. So what we do is we've got a copy of the tiles that when you poke into memory, we work out what it's going to be and we cache it, so that when we come to draw it, it's all set and we can just read that value and store it into memory. And it's basically bytes we kind of do, and it's all kind of simple 256 color stuff. So again, if you're rendering into tile memory, then it does this. There's several different banks that it can do this too. And it will record, and it has to put this into memory as well. So it does all this, and then it will put it into the actual bit of memory. So every peek and poke goes through these functions. Even in the debugger, nothing goes like behind the scenes and do stuff. It all goes through this because it all has to decode and do all this kind of stuff, which is a pain. So div MMC page down. So I think this is writing to the MMC RAM. Then again, it's got to do that. So MMC RAM. Unlike the next that has one big contiguous chunk of RAM, and then it steals parts of it to do MMC parts, or the ROM kind of pretends that area. I've broken it all up into bits, so I've got my, you know, actual RAM, MMC RAM, and ROM areas, all separate arrays. For a next programmer, it really doesn't matter. So just doing it again for tile map stuff. You know, paging in, it's got to go through the whole shenanigans again. If you've got the alt ROMs paged in write mode, then you can write values to them. So I mean, it's not something that's really been used yet, but you can take over all these ROMs and write data into them if you're running out of space. There is areas you can write. You won't be able to reset, you have to switch the machine off, but you could do that. And then it gets into normal peeks and pokes, where you start writing to, left 2 going in, you're going to poke into that. T-states for that. You go through the banks again. So this is just normal memory. Again, depending on the banks that are in, you have to do all the tile map stuff, or it just writes in. So peek and poke, as you can see, are pretty complicated and pretty large. And again, it has to do this for every byte it reads from memory. We don't do any shortcuts. So again, you know, even you're poking a word in, so HL, it does one, moves it up, does the other one, because it's got all this to go through every single time. It's not pretty. Okay, so where were we? Main, execute, right, over here. So that's just getting the opcode. So based on the opcode, so you can see here, we just go T-states, basically return. So these are all the simple ones. dgen Z is the loop. Got B, it does the loop counter. So that's looping back. That's just going forward to the next instruction. There's a whole load of stuff. If you're interested in actual emulation stuff, that there's a whole load you can kind of do with it, and things that will take you through it. My 6502 articles actually that are up on my website would walk you through the basics of it. Fundamentally, you know, it does its thing. Like I say, this is all pretty old. Late 90s, I think this was done. So execute ED. So this is where a lot of the next instructions come in, where we've added custom instructions. But it does it as you'd expect. You know, it just kind of gets the values, does the op, and returns with the number of T-states that it's going to take. They all tend to take less T-states than the other ones. So again, there's the 11. Now it did do some, it's all the add ones. So here you can see I did start playing with the idea of moving it on to try and see what the delays were in contended memory, just to see if that was having a big impact, and it does. But this is what it should do. Each time there's actually a bit at the top here where we advance from the first byte, so we read and then take it back because not every instruction does it. So that moves it on to the 8 where it should be, and then it does these memory reads, and that makes those T states a lot more, the wait states a lot more accurate, and it does actually produce much better results. But it'd be a huge undertaking to go through and do all these individual operations instead of just what it is just now, and I'm not really fussed for what it is. That was really just a learning exercise. So we've got all the new opcodes in here. I don't think there's any one that's really particularly interesting. The LDI scale never got done, if I remember correctly. That was supposed to do scaling drawing, I think. That was one Jim wanted in. To try and do an LDIR that scaled instead of just copied. It could basically do your like do molds and stuff for you. So it was written when they were going in. I was writing test ones so we could write test programs to run for Victor to try them out. So a lot of the instructions were put in and then cropped out later. Fix the time one. Yeah, as I say, it's pretty straightforward. Yeah, scaling would be nice. It's a bit meh. Yeah. I mean, with the memory that we've got, that you look at the way I did the Wolfie stuff and just pre-generate code that just does load store, load store, load store, it's probably quicker than the LD scale anyway. The LD scale would be a lot easier to use, but it's probably quicker and more accurate because you can do full 32-bit maths on the PC to generate, the actual scale values and which pixels it's reading, which you wouldn't be able to do on the NEC. So it would scale quite roughly compared to what just pre-generating the code would be. It might be an idea to do basically take that code that I've got and do a separate function that will generate your code to scale, and then you can just page it in and call it if you really wanted to do it. And it'd probably be just as fast, if not faster, because the LDIR stuff isn't super quick. We know if you unroll it, it's going to be faster. So, well, okay, blitter's different. Yes, we want a blitter. That would just put it on the blitter and it'd be great, because then it's not having to do all these stupid Z80 weights and funny loops and stuff. Yeah, even a blitter block copy would be amazing. I'm going to bite my tongue now. So anyway, that's all the Z80 stuff. Then we get into kind of loading, but we'll get to that. So that's the main loop. What else have we got in here? I'm less worried about wavetable stuff because the sound chips are okay that are there, the AY stuff. But then you've also got 4-channel digi, so if anything you want DMA for the digi stuff, and then you could just play samples if you really wanted that. I think what we've got's okay and gives you that decent kind of challenge. Right, so where to start? That's the kind of core loop. There's obviously a whole load of stuff on top of that. Let's see. So what about the SD cards? Yeah, 4-channel DMA for the stuff would be nice. But yes, you'd have to scale, I guess, to be able to get it for any note. Okay, so SD card interface. Now this is actually what SD cards do. So if you're ever connecting wires to an SD card, I did this on Commodore 64. You could connect the SD card directly to the user port, and then you could send bits down, and these are the commands you actually send the card. So we've got this interface for doing it. Yeah, it's all the different formats of the card and so on. And this is what lets the next stuff, the next OS running on the emulator. So you've got read, write, and byte. So it's basically a port on the next that is, yeah. Wait for the big refactors and then see if the space freed up for all these extra things. Although it'll just add to my headaches for trying to emulate all that stuff. So there's basically a port on the next that you send it to it and it sends it to the card, and in the background it serializes it out and all that kind of stuff. So you're basically presented with a byte command back and forward. And you've got the different commands that get sent over. So those commands are, read block, write block, and various statuses. The most important ones are the read and write. So the SD card will always read and write 512 byte blocks. That is not sectors, as in a disk sector, but just blocks in this massive SD card. So you can see here that when a command's sent, we get a command packet in, it builds up this thing and it will read from the image whatever it was asked to read from that packet. So the packet is just, it's the command and the bytes that follows. That's standard SD card stuff. Again, you can Google what the SD cards take. Reading SD cards electrically is great fun. I've done it a few times. Did it on the Commodore 64. I've done it on Raspberry Pi. I've done it in Game Maker. And at some point I will do it on the next to do like fast file loading, so you could kick out the whole OS and just do it all yourself. You basically just have to understand all the formats and directory structures and long file names and all that kind of stuff, which is fine, and it's good fun. So once you open an SD card image, which is that massive, 2-4 gig image that you download to run the next OS, it basically gets the sector times the 512, and then we read it in, stick it into the sector buffer. Well, that's a bit of debug for me, just to print the sector for doing what it is. And then we build up stuff that will be sent back. The 255s are terminators for the SD card. So when you're writing, you wait for these numbers to come up, and then you can start reading stuff. So you hit 255s, 254, then you can read the raw data. Then you go 255s out again once you've done it. And all that gets passed back to the next. So once you've built up a sector, there is a command there that sits and loops around every time a read is executed. So when you do a read byte, yeah, if it's starting, it does that. Otherwise, it does a send data, which is just gets the next byte out of that send buffer and returns it to the next. So all the next is doing really for the OS is asking for like 512 byte chunks from the SD card, and then it does everything itself. It does all of the directory handling. So it just really pokes into this port. So let's have a look at that. We haven't done in and outs. So these are similar to peek and pokes. You've got your port logging, where we can write out stuff when ports are activated again, another debug thing. We've got the plugins. I technically don't need that now, we could do it as a plugin. However, it's still there. And then we've got all the different ports that we read. Yeah, basically the streaming stuff is kind of like that. It just gives you something to read, sets it all up and then you just read from there. Yeah, kind of. I suspect if you did it yourself, the streaming stuff, if everything's not in a single, what do you call it? A single contiguous block of data, then streaming is a faff because you've got to decode clusters and so on. And in general, folk didn't want to do that. If you were doing it yourself, that would probably be easier, and you wouldn't have to rely on people defragging everything to make sure it's all in one big contiguous block. There's not much of a calculation needed to go back and forward between them, and if you were doing it yourself, you could cache some of this so that you could chain them all up, so that it's, the data could be scattered, and streaming wouldn't really be that complicated then, because asking for another block of data is not that bad. It's just that dereference to get the sector and the segment offset and all that kind of stuff that takes the hit. So ports, this is memory paging for 128 stuff, although the Next does use this as well. Fortunately, most people now just use the MNUs to do its paging, but it is still there, you can still do stuff with it. The +3 stuff still uses it as well, and there's some of the +3 stuff that's still used in the Next as well, just to complicate things. Yeah, I need to fix the streaming audio on the simulated stuff, because it was working but it's now broken. So, right, so that's all the ports, kind of normal ports for there. You then got the Spectrum stuff, which is the audio, and the DACs, so the different ports for those. So when it comes in, it just checks the port and then it sets it or doesn't set it, and then the main loop, when it's doing the digital stuff, picks up these values for building up the sample buffers. Got the UART, so if it hits these, then it writes out to the different streams. Okay, nothing complicated, just it'll write those things out. And you've got DivMMC stuff, which is the port for writing to the SD card and reading the SD card. So that's the different ones. You've got, I think this is the selects card. So depending on which one that was set, it will go to the different things. So this is the main one for writing to. So, comes in here, does the write command, and then processes the command, and so on. So it all kind of works together. You can kind of see there's a lot going into just getting these kind of basic things working on the Next. It's one of these things of, if I hadn't started writing this when I did, I would never start writing one now. It's huge and very complicated. Fortunately, when I started, it was just sprites and 256 color bitmap, I think it was. And the sprites were more basic than what we've got now. So all I had was a Spectrum emulator that could do a 256 color layer on top. Initially it was on top, but we did put that in order, and then just the sprites. Yeah, it was a lot simpler. And then it just, as the hardware came along and evolved, things got added and added. So it was done in kind of piecemeal, so it wasn't one big huge task. If you were doing it now, gee, it would be painful. There is so much to get the most basic thing running. Yeah. it's just, oh, yeah, I would never start one now. Never. It's so complicated. Oh dear. I mean, it's almost like trying to write a new Amiga one now, isn't it? Is it more complicated than an Amiga? It's different layers and stuff. It's just, I think there's more hardware in it than an Amiga. Because it still has the copper, it's got all the DMA, it's got more screen modes than the Amiga has. Yeah. Yeah, yeah. Maybe someday somebody will come along and write a fresh one. So again, you got the writes, you got the DMA, timers. You can write the ROM banking in there as well. Layer 2. All this was done through the ports as well. Turbo sound. Then the AY chip. Now the AY chip is done through an external DLL. I did not write that. Somebody had already done it, which I'm very grateful for. I do think if we could, I'm trying to move more and more the hex toggle. What hex toggle? Oh, and the debugger. Yeah, somebody had asked for that before, but it was making the code much more complicated, and the debugger. And it was just making my life a nightmare. So I'm afraid it was dropped. Having everything in decimal in the debugger was just a nightmare. So sorry. Although in theory, you can now write a debugger in the extensions. In the plugins, you could write your own debugger that is all decimal if you really wanted to. Yeah, it was so complicated to keep it going. I'll get to the debugger and you'll see what the code's like as it stands, and then every time I print something, I have to have an F for doing all the different renderings, and it's horrible. Yeah, it's horrible. Anyway, so the sound stuff, yeah, goes through this extension, so which I haven't done very much of. Like I say, I did an interface to it so that in theory we could swap it for something else, and then did I do this bit? No, that's not mine. AY chip. This is mine. Right, and it basically just calls down into the code. I think this was all C before, and I C-sharped it, so could use it. And I have done sound emulation stuff before, and it's okay. I did a SID chip emulator for my 64 emulators that I did. But being able to just take this and plug one in, and this just does 3 channels. So again, I've got 3 of these all running. And they just get passed different values. So there's that read that comes from the outs, and read and writes. So we'll go back to ZA2, wherever the hell that is. No, I've lost it. Yeah, so it goes through the writes and just goes to those plugins. So this is actually provided with CSpect because it's an open source one. So the source is provided. You can compile it up and do your own one, or extend it, or do whatever you want to it as it stands. Like I said, this was all C to start with, and I C-sharped it so that I could use it, because I really didn't want to have to do my own. I took a wee bit of jiggery pokery to get it working. Yeah. I should find, I mean, the link's probably somewhere in here. I should find where it came from and then give them the C# one. There we go. Give them a C# one to have as well, because it is handy these days to have the C# thing. Basically, this just generates to a buffer, and then I use that buffer and mix it and output it to my own stuff. yeah, I don't know. I put this in and then never looked at it again, so I'm not quite sure what half these things do. This is the main bit for generating the buffers. I just pass in a buffer that it fits, it fills it in, and then I use it. So, and output it, like I said, I've got 3 different ones, depending on the one that's being written to. So, yes. And you've got all the next register stuff, because you can write to next registers with ports. That was before we had the extra commands for doing stuff. That was a godsend getting the next command. I still really want a next register read. We've only got writes. Being able to read any next register into like an A or something would just be amazing. It's another one Victor refused to put in. So you always have to read it through the ports, which is a pain in the arse. Particularly because you've got to read the ports to remember what it is, so you put it back in and interrupt routines and stuff, when instead of just going read the register. And you've got sprite stuff, because again, sprites were all ports as well. Yeah. So you got writing to all the different sprite port stuff. They kind of go through in sequence. For all the different sprites. Oh God, I've not even got onto the rendering yet. Jeez, I forgot about that. You can see how big this is blown over time. I mean, it is just huge for what it is now. You've also got the sprite data. So like the tiles, when you write sprite stuff, I build up versions that I can render much quicker. I don't decode from memory all the time, because it's just too slow. So I build up sprite versions of them that I can just blat through and draw very quickly. Most of the time they started out as 256 colour anyway, but then we've got the 16 colour ones now too. So that's held in its own memory as well. I think sprites, I've put some space at the end of the 2 meg and it just come down from there. And then sprite offsets. All the sprite arrays is like a big pool of sprite classes that I keep for looping through and rendering sprites. And we've got the cut. Geez, not done any. Yeah, there's so much in the dry. I'm just looking through this going, I'm never going to be able to go through. I'm never going to be able to do dev today. I'm going to just spend the whole day just going through it, because there's so much. Okay. Then we've got the border. And that's like thingy stuff again. So there was a bit of ULA plus for a while, and it came out. I refused to put it back in. It's crap. And then you've got import, which is the same again. Some logging extensions, and then you've got all the different kinds of reading for the different ports. So you know, your joystick stuff. Well, the 16 color 640 isn't there. Layer 2, isn't there? 326. Yeah, there's a high res. There is a 16 color high res. Yeah, 16 color is always a pain because you're writing in nibbles. I don't like that. You're quicker just blatting in bytes, so you don't have to mask it. I think overall it would end up being quicker. You use more memory, yeah, but it is faster just doing the 16 color stuff. So the joystick stuff, Mega Drive ports. I haven't used the joystick in ages. I don't even know it still works. I haven't used it in yonks. Reading port. There's the special Cobra fix where it reads the ULA attribute, which a Cobra kind of waits for the end of the line, waits for the end of the screen border or something, waits for that last magic character. So I've got to work out where I am and read that if you do an in on that port. for the floating bus. That was what we're called. Yeah, if you've got Timex mode on, then it reads that or something. Otherwise, you get the floating bus, which is a pain in the bum. But it is nice seeing Cobra run. Cobra's very pretty. Read the DMA. What the hell is this? Oh, this is the mouse. So this is the bit I want to move into an extension, because it would be nice for somebody who does lots of Mac stuff to fix the Mac. I do have a Mac sitting here. It's never used. There is a bug in OpenTK that means that the mouse does not work properly, because really I want to click the mouse and then lock it, so I just get offsets for it. But that just doesn't work. Setting the mouse position in OpenTK is bugged and does not work. I really don't want to recompile OpenTK. So if I could move this into an extension, then somebody else could do it. Technically somebody could do it already, because it's, if you look at the extension stuff, if it's handled by an extension, it just returns. So somebody could take over. Where the hell's it gone? Hang on, NB. Yeah, so that's. So if you're reading, it takes over, it would just return. So somebody could take over these ports and do the mouse. You don't actually have to move it out of here. So you could do a fix for the Mac stuff. That was one of the reasons I did the plugins that way, is so that even if I handle it, you could take it over and do something else or fix it or whatever. There's nothing stopping you. You've got kind of total control over everything, pretty much. Even things like memory and everything, you know, you could do your whole new memory system if you really wanted to. There'd be nothing stopping you, because when you do peek and poke, you know, you get in there first and go, I've handled this, and it wouldn't run any of my stuff. Obviously, I have to be careful with it, but you know, you could put an extra bit of hardware in. If you poke to this address, something's going to happen. It does mean if somebody writes hardware, not writes, but creates hardware for the next that plugs in the back, and then maps to some address or something, then or some port, they could write a plugin that simulates that hardware without me having to do anything. So there's the SD card, turbo sound, multiface, reading of the registers, so that's the current register selected, and then it goes through a big get, which reads the next register. So there is certain registers that you have to do with stuff from, and then there's a big pool of them. So next registers, let's go down, hang on, just find the next. I want to find set register first. Oops. Okay, so when you set an X register, again, got a plugin, you could go off and add your own X registers if you wanted. First of all, we've got basically an array of 256 where we store any value that's written there. There's some that when you read are always 0, so they always just get blatted. I could change that for the set and just put these values in and return 0. That'd be fine. And then it goes through and just, you know, sets up the peripheral, sets turbo modes, all the various things that these registers do. The clip stuff, you know, it's got to set a value, then advance the index and all this kind of thing. But fundamentally, when you set these values, it goes into an array. Yeah, it just stores that value for later use. So when you do get, if it's not one of these ones that you have to do something special over, it just returns from that array whatever you wrote to it. But there are ones that are special, things like the raster lines, the current raster, all this kind of stuff, turbo, anything that takes a little bit of thought, a clip index, you know, it will build that value up and return it. color palettes. Yeah, color's another big thing. I did have to do a big refactor a while ago to change the way the color was working, because it was just getting, when the 9th bit got added, I seem to remember, because it was 8 bits for a while, and then magically this 9th bit came along just to make my life hell. Yes, 16 color layer 2 is the 640 mode, isn't it? And it goes in columns or something, not rows. Well, you could just write the 2 values twice, then you get yourself a 320 again. So just double up. Yeah, so when the 9th bit got put in, that seriously complicated everything, and I had to go and refactor all the palettes. Copyrights, yeah. Oh, stackless NMIs, jeez, yeah. Every time I see some of these things, I keep thinking that was another bit I had to fudge in to get working. It's just, oh. Right. So that's all really the processing part of it. So every time an instruction's executed, every time it reads a bit of memory or out support, it's got to go through all that stuff. And that's the processor running. Whether it goes to the SD card or whether it goes to audio or DMA. Trying to think of anything I've missed. Install ROM structures. Structures. Oh, next files and stuff. Yeah, okay. I haven't done loading. Let's quickly do loading. Can't remember where it is. Right. Loading. Very quickly, because there's not much to this really, in the grand scheme of things. A next file can keep the file open so that you can get that handle from memory and then just seek and start streaming, so the file can move and it can be renamed and all that kind of stuff. So when you open another one, you've got to go and close everything. That involves resetting the plugin manager, because it's now all the file stuff is in the plugin. Fortunately, these are all up on GitHub. You can go and look at them to your heart's desired, so I don't need to go over them. Other than to say the A6 DOS one is basically all the file handling comes from here, and that means yeah, SD card, that's not what I'm after. There should be a list of, anyway, it's all in there, you can go and look. That handles all the file stuff. The seeking stuff is in there as well. It is broken. If somebody wants to fix it, that'd be great. Where was I going? Lost my train of thought again. Yeah, okay, so Z80. What was I about to do? I was about to look at something and I got sidetracked into the SS stuff. Structures. Next file loading, that's what I was doing. Okay. It's done now. Right. Yeah, so it closes the file handle. You can pass stuff from a command line. Or it will do F2, it'll use file requester to open up and ask for one. It'll then try and read it. It just reads the whole thing in, doesn't do anything fancy. And it will set the path to wherever that came from, just to make life a little bit easier. It then tries to reinitialize the whole system, because you've loaded in a snapshot image basically. There's then a .next, .tap, which hasn't been done yet. At some point I might do that. Or it's an SNA file. I did have 128 SNA files loading, but when I moved from C into C sharp. I never got around to fixing it. So I didn't really care too much. There was very little that was a 128 mode thing. So next stuff, we set all the different things to make it a command line next file that's loaded. Again, we go through reset all the memory, and we actually load the file. So it checks to make sure it's the next file, and then goes through and just does what you'd expect. Like, you know, gets the loading screen, gets the banks, copies stuff into memory. Doesn't do everything. Could this be a plugin? Maybe. I think there's a couple of things it needs to reset that you couldn't really do. It does some of the tile stuff, so yeah, possibly not. It'd be a bit more complicated. Because as you load in, it's got to do the tile thing. This is one of the few things that goes straight to memory. It doesn't actually do poke, because that can be triggering of things that auto increment and so on like that. So it does it here. Yeah, and it just copies it, and then sets up the address, sets up the banks. This is where it gets complicated. This is a fix that's just gone in. It's not public yet. With the file handle being opened. So I've got to open it here because I know what it is, but I've got to pass this over to the ASX plugin, ASX-DOS plugin. So I execute a special command, and it then copies. There's a couple of globals set up. Where are they? Global for the next file name. So it gets that. Is that a file name as well? There we go. Next file handle. Oh, it's already in there. So the plugin, when you call the ASX plugin like this, it can ask for globals, and it gets these two things. So it can get the open file handle and the file name, and then it passes back a next file handle. So that's that single byte thing that the next uses, and then it gets poked into memory. So that satisfies keeping all the handles on the other side. So like I said, this fix isn't in. It was broken from when I moved all the CSX stuff over, and then just sets all the registers and turbo mode, and then off it goes. So right, so I think that's all the hardware for the CPU. You can still load the SNA files, but they're all the same. This isn't covering the debugger yet. Let's quickly look at the debugger before we go into the rendering. Okay. So, yeah, debugger. Where to start? Alright, so there's two parts to the debugger. There's the process, there's the render. Depending on what you're doing, it's going to do the different commands, basically. Step, rewind, move bars up and down, as you'd expect. It's all just kind of normal stuff. The rollback's always interesting because it's, it's because of what it does. More. It makes me cry every time I look through it all. See how much crap there is in it. So it's moving the bar up and down. You can page it up and down, you can move it up and down. Breakpoints, so on. So there's nothing, no rocket science in there. We've got execute a step, which does. Oh, I'll get to the render in a minute. Wait till you see what that is. That's even more complicated than everything that's gone before. Yeah. execute step's got to basically do that CPU loop that's in the main loop, kind of here as well, to simulate most of the stuff. So it's large and annoying. So you've got step over. So step over is looking for jumps and branches and so on like that, and then we'll put a breakpoint after it so that it can execute, and then jumps over, and then it will come back and debug when it hits the breakpoint. It halts and get the same kind of thing. It just executes until it gets past the halt. Let's see, message. Not easy to point to in the other memory. No, I mean the render, if you're in the debugger and wanted to see a different screen, the render is basically rendering what you've told it to render for the hardware. So if you've pointed layer 2 to someplace else, you're seeing the display screen. You're not seeing any of the shadow screen or temp buffers. It's showing you what's on screen. Could it show? Well, you can't really show any other screen. Things like tile maps and stuff are all single screens anyway. And while you've got the 2 ULA screens, you might not be using them. So you can't really just go, well, show me the back buffer, because it's not that simple. Only layer 2 has what you'd term as a shadow back buffer, and not everybody's going to use them for actually rendering to. They might just page stuff in and draw stuff. So the only guaranteed thing to have a screen is what's being displayed. So, right, so this is the debugger render. So, clear the screen, draw all the lines in pretty frames, and then we start going through and actually drawing stuff. We'll get to the render in a minute, because that's changing. So you can see why having a decimal version of everything is now a major pain in the arse, because you've got to do all this again. All these change to just decimal values. So you basically got the whole debugger twice for its render, just to display it in decimal, when in fact you could just, if you really need a number in decimal, you could display it in, get Google to convert it or something for you. Because if you're in assembly, you really need to know hex, has to be said. And it complicates life so much if you're not going to do hex in there, because you're going to use 1, 2 or 3 characters for things, whereas hex is always the 2 or 4. It just makes layout so much easier. So we've got drawing stuff. Draw text. I use the Spectrum font to draw things. Yeah, you need to do some hex. We all use decimal now and again, but you need to get used to hex. We've got 2 different ways of drawing things. In fact, 3 different ways of drawing things. One is as an 8x8 as a 16x16, and another one is as an 8x8 or as a 16x8. All just using the Spectrum font, basically. So this is draw small, so this will be the 8x8. So we just draw foreground and background colours, and we draw a character. So as we're drawing stuff, it just goes through the characters and then draws. And then we've got plot is just pixel plotting on the screen. Draw character. Got the thin one, which is 8x16, and the big one, which is 16x16. So it's as you'd expect. And it just goes store, 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 store. But again, all comes from the Spectrum ROM character. It's a nice fixed width font that everybody kind of is used to using. So the main disassembly is the bigger one. The memory window is the small one. It does get very small. We actually run come on. So we actually run, so this is the 8x8, 16x16, and that's the 8x16 that you can see there. Again, 8x8 stuff. So, you know, it's, yeah. While I'm in here, we'll just show we've got the new Next Register display plugin that kind of shows the new stuff. Not everything's in here. I'm hoping community will be nice and go and extend this and add to it. So we obviously don't use the full registers, but I've got them all kind of mapped. As you go down, so 32, so register 56, sorry, 56. So here, it's about to set. So it changes colour, show you what it is, and then it'll go back after a little bit, just to show you things that have changed. So you can kind of see it live there. So these are changing all the time. That's the MMU. Don't know what that one is. That's the scroll. Yeah. Global transparency. So yeah. So that's the main part of debugger, drawing all these things. Basically there's a line, horizontal, vertical line draw, and then text drawing there, it just dumps everything out. And then we've got the drawing of the little mini screen, which I might take away at some point because it was just, I had a big gap there. But I think extending the window above it to be able to display more information would be better than just displaying that little screen. I don't know if anybody really cares about that little screen, do you? I don't know. Then you've got the hex dump, which we also have editing and stuff in there. So as the mouse is over, it will highlight areas so you can click and edit. Yeah, hex edit address. So it figures out where the mouse is and then lets you edit inside there. And then that's the thing. This is another reason why decimal would be a nightmare. Trying to fit, it would all change depending on the values. It's just, it's nasty. And then draw switches. So there's a new switch for source level debugging, which I can't show at the moment. It's a bit broken. So the disassembly, we've now split into the two parts. Render source basically gets the file, looks up the file it's coming from, and then finds the address in that file that we're doing, and we'll print that line to be able to render source level. I don't know if I've got. Let me just see if I can. That's an old one, but if I now hang on a sec, just seeing if I can actually get into that. That one. I don't know if this is going to work, but we'll give it a go. I think I might have hardwired it off at the moment just to try. Yeah, it's kind of been disabled at the moment, so never mind. We'll get there with the source stuff at some point. It's nice. The source level debugging also has a little bit of color coding in it to try and simulate more what I see with my this kind of view. So it kind of copies this kind of colouring. I am thinking about putting in a preferences thing so you can change all the colours, but at the moment I'm not fussed. Yeah, so it goes through and does a little bit of parsing on the line, source line it gets back to try and figure out what it is, and then it can colour things a little bit nicer so you get a nice view. It would actually be nice to see the source level. Let me just see if I can enable this thing. Where's the map? Let's see, hang on. That's low res, that's not what I'm wanting. Hang on. So beast. Oh, I need the new SNASM as well, don't I? Hang on. SNASM. So that's my assembler. This is a beast unto itself. Let's run that. Let's see what this does. Ooh, there you go. So that's the new source level debugging stuff. So this displays the source, but you get all your comments and stuff as well with it, so it's nice. I didn't mean go on the keyboard one. Yeah, it's nice being able to see all the comments. But like I say, at the moment, it's actually stepping through the assembly line and then finding an address match of that in the source and going, that's where I am. I think really what I want to do is to have it go, this is the line of source I'm in. I'm about to step, what's the address of the next line of source? That way this could be C code and the address would be on the next one. So that would be quite cool. It would make it more useful, I think. But it's a start. Can certainly do more. If I can get the debugger into a separate plugin one day, then it could be done anything. But really, the DZOG thing. If you want a full, source debugger thing, then it's in Visual Studio. It does everything. Yeah. But this does all that colouring. Like I say, it parses it. It looks for IDs or strings, and then there's a list of opcodes up here that are next opcodes that we kind of colour a little bit better. Got the normal Z80 and you've got the next ones. If I wanted to break up, in general, I just recognise it being an opcode and we'll colour it as that. And then the register types. And that's the debugger really. There's a bit of lex parsing for the commands. So you can type in the commands at the bottom. It does. Gets an X word, so when you type something in, it goes and parses it a little bit. It's nothing spectacular, and then depending on the command, we'll do whatever it's asked to do. I've not actually tried using Dzog. I should, because it looks very pretty. I'm kind of too used to my assembler and just text editor mode. Anything I need I tend to put into CSpect debugger. Oh, you can actually do registers as well, can't you? So, yeah, there is a save now, which I keep forgetting. There we go. So you can save memory just straight out to the disk from there, which is bank offset length, bank offset to bank offset. I should do a 64K one as well, which is just that comma length. That would be handy, because I don't do the bank all the time. And then that's writes out to disk, which I've been using that a few times. So that's debugger. We've got a big disassembler, big old disassembler. Z81, nothing interesting. Symbols, as you'd expect. Yeah, it's quite old. Just a straight symbol table. So, are we ready to go into the actual 3 o'clock, geez. Rendering. I think so. Okay. Rendering is where it gets really messy. This is the bit I'm most embarrassed about. Right, draw scan line. Okay, so remember we are scanline based. So we execute a run of Z80 things. It does all its shenanigans in the background, and then once a scan line, it will call this to actually render. Now, you've got 3 different segments, which is top border, screen, bottom border. You've also got, how many modes? You've got the ULA, you've got layer 2, you've got tile maps and Timex modes, and then you've got various resolutions of each to kind of cope with depending on different modes. So you've also got the ULA next mode where you can change all the colours, and you've got transparency and fallback colours and all that kind of stuff for each of them as well. So in ULA next mode, then we pick up some transparency colours and border colours and stuff, and Timex colours as need be. ULA next is off, then we kind of try and get the normal default colours from everything depending on what's on. Again for border colours and fallback colours. Now this is C# for doing direct memory access. So back to pointers again instead of manage memory. Because you don't want to be using array. Every time you put a value into an array, it'll bounce check. It's incredibly slow. So we just get a straight pointer, like C++, and we can just poke into memory with that. So we check to see if we're in the top border, and then we will do a scan line. So the draw top border in general is just fill it. Yeah, I'm used to my code being a bit more elegant. It's just the way the neck's put together. It's nasty. I don't really like it very much. It always seems like a fudge. So most of this is just getting which colour we're going to draw with. the top and bottom border point of the screen. I will still emphasize, even if it's wrong code, put in comments. So that's, the top border is pretty easy, just fills memory. I think this is a uint, yeah. So it's doing 640, my screen's 640 wide. It got extended when they added the 640 mode. It was 512 wide, I think, but it had to be extended when they added a 640 high res mode because they love me. If you're in the main screen, then we still got to get all the colours. Then we draw the side border. And the right border. Blanket row. Yeah, we've got to loop through and just clear the row in case nothing's being drawn, and then you get the fallbacks and stuff. So if everything was a fallback colour and it goes transparent all the way through, then basically the last ditch colour is going to be black. So you have to fill that with black just to make sure that it's got the right thing on there. So there's lots of this kind of thing in the rendering where it just fills whole rows constantly. That's one of the pains, is that we're forever doing big loops over things just to make sure that that's clear. This is set, this is set. It's not particularly nice. So this handles the main, just overall control of drawing a scan line. And then we get to the actual guts of what happens when I draw a scan line. So you've got all your different orderings, and that means you come into things have to be ordered in specific ways. So every time there's a different layer change or something, it's kind of got to go through. Now this was all fine until they added those pixel priority things with the palette. So if certain bits were set in the colors, then it would be pixel would be in front of like sprites or tile maps or something like that. So in this one, which is 0, you got the ULA at the back. So if we're not in a border, so that's the top and bottom border, because it still has to call this for the top and bottom borders because of the tile maps and stuff. They fill the screen. So if we're not in the border, then we'll draw the ULA. Then the tile map gets drawn, because they're kind of bound. Although there is weird things where you can now layer sprites in front and behind of stuff, which I haven't done yet, which will make this even more complicated. We then do a merge of the tile map. So everything is drawn, doesn't go straight to the screen, it goes to a work line, and it does like scrolling and stuff, and it builds up this single scan line, kind of like the Jaguar. Builds up the single scan line, and then we blat that, and it's built up in spectrum next color, so you know the kind of byte value that gets written there. And then when we come to merge, it kind of decodes all these things. So if you go to the draw ULA, there's obviously several different modes of ULA. You've got the Timex high res, Timex high color, which is the per line. You've got the low res screen, and then you've got the plain old ULA, and that's all comes under that ULA, guys. So we've got different ULA screens. So this is the classic ULA. And remember, ULAs can also scroll now, so you've got all the scrolling offsets to add. It looks up the attribute and everything based on the scan line. So it's basically that the scrolling is just working out. We only do Y scroll here, because it's 32, and when you scroll left and right, it basically takes that line, starts it somewhere else, and then wraps round. So the merge of the ULA screen does that. So here we just work out the line that we're drawing, and so once you've got the line, but it just offsets and pretends it's a different raster line. It works out the attribute that you're ready to do, and then the screen line doing that funny, you know, the way the spectrum screen works. And then again, we've got to blat the line if it's outside the clip or anything like that. So this is the clip. And then we've got to clear it even if we're not drawing. And it gets cleared with that global transparency. If it's within the clip, then it does a normal draw, which is runs through, gets the attribute, and then if it's flashing, flips them round. Yearly next mode completely changes how it works because you've got these funny shifts in there. Jeez, there's just so much. Every single thing of the next, there's just so much to it. Honestly, if you ever think about doing a next emulator, just don't. You really just don't want to. Dear. Yeah. So it does lookups to these things for from the different color palettes. And when it actually comes to draw, it puts in the actual colors. So that's just a straight, it goes through and draws it for that scan line. That's the standard yearly screen. Yeah, so then you've got the high color, which is yearly screen, but an attribute every scan line. So it just does kind of the same thing, but you get an attribute every scan line. So it's like the normal screen, but an attribute every scan line. Then you've got high res, which is mono, but just high res, basically. I can't remember the exact format of this. Yeah, I think it just goes twice the, that's just twice the size, isn't it? Yeah, it really does. It's just, I'll say again, if I hadn't started this before, would never start one now. Anybody that starts the next emulator is insane. Low res screen. So this was the raster screen, which evolved into the 256 color low res. Was it 128 by 64 or something like that? Can't remember. There'll be a loop somewhere that tells me. This can scroll in half pixels, just to be nice. And again, every time it's off, you've got to black the line to clear it. So it fixed 2 bits of memory in place just for fast drawing. Raster mode. 96, that was it. It's not quite raster mode though, because it's a next one. The raster mode one was weird. 12 color one or something. It was a weird format, 4-bit. So it's 4-bit and 256 color. So that was the original one. And that's the new one that was the next added. But it's in 2 banks, which the Wolfie engine that I did was started using. So it started off in that. So yeah, 4-bit or 256 color. Yeah, it was. It was in that Rast and Jim mode or something. Is that what I've called it? I'm sure I've got something somewhere that says calls it Rast and Jim. Yeah, it was Jim's fault because he was wanting to do. You were wanting this mode for Wolfie, weren't you? You thought you'd be able to do the Wolfie engine in this mode because it's a lot less. But turns out we've managed to get it in the full low res one. It's a nice mode though. It's a handy one if you want to do anything fancy in it. It's too much power for everything else. So there's the 4-bit rendering. Yeah, but it's fudged like hell as well, the Wolfie stuff. Jeez. Yeah. I think you could do it quicker if you used BSPs to render it instead of the way Wolfie works. It spends a whole frame doing its traversal. Yeah, full 3D, I think the layer 2 would be just a bit too painful for, but it would be probably fine in that mode. So that's the 4-bit, and then the 256 color ones just copy. It's very simple. So that's low res. Then you've got tile map. That's not this. Yeah, Radagem. There you go. That's what it used to be called. Radagem. So that's ULA. So that's all the ULA ones. Now, does that not go to... I thought there was a merged ULA as well in here. Hang on. Oh, there we go, ULA scratch. So it draws that. And tile. Right, so there's two tile map ones. One that's below and one that's above. Jeez. Right, okay, so let's do the draw tile map. So tile maps are... yeah, you've always got to clear. So tile maps, you've got to blat the whole line every single time you draw it. It's just really painful. And there's two screens because there's an above and a below. Depending on where the tile is, it's going to be above and below. So you've got to fill both of them every time you go to draw a scan line. Yeah, it's per tile or something, isn't it? It's just... So it comes in to draw it, and then we've got... Oh, fucking hell. Fixed. Fixed. So we've got the two screens. Date start 8. Start 8. 2, 2. And tile sets. So the two screens we're drawing to, the maps were coming from, then the tiles themselves were coming from. Again, so we don't have to access C# arrays, we just take byte pointers to memory. So it's quicker without any bounds checking. And then you've got the hell that is drawing tile maps. There's another one. A tile map address. Do these not rotate as well or something? Yeah, tiles above, tiles below. So yeah, each tile will go to a different scratch, basically. So you imagine we've got the two different scratch lines, and then depending on the tile bit being set, we'll draw to one or the other, leaving the other one as the global transparency. So when it merges, it combines to the image. How long have I been going for? Fuck me. Hang on. Where's the time? 2 hours so far. Jeez. I don't know if I can code review. Right. You've got text mode as well, which goes mono, which comes from that data that we pre-generate whenever the zombie does poke to memory. And then flips. So flips are a pain in the arse. So what I end up with is, instead of starting at the top left and just doing increment, you can start at any corner, and then the drawing direction will be an X and Y value. So it can be going up an edge or backwards or something like that, so that we can flip and rotate every single tile. So there's a delta and a Y position start. So the delta is basically X and Y added, because it's an address we're going to, and it's not like an X and Y, it's just an address. So going forward 8 would be the next line down. Going back 1 is 1 pixel. Going back 8 is going to the next line up. So we start, this one would start like at the lowest corner, and then it'd be going back up whole lines. These are a pain in the ass to sit and work out. It really was. I think Kev gave me a whole load of tests to do this, because I would never have done this and all the tests to do as well. It's hard enough getting all this stuff in. Right, so this draws a single tile, so 8 pixels across, gets the tile stuff. That's the tile itself, and then looks up the colour, because they're all coloured, aren't they? So the palette is using the colour, get the index, checks for the global transparency. If not, then gets the color and then stores it in the screen. And then we've got the tile base, which is the pixel of the tile. We then do our flip and merge and whatnot. So that's if it's text mode. So it's almost the same because we've turned the text from being a single bit into 256 color just to make it easier. But there is a little bit different in, yeah, it doesn't have the color lookup because it's mono basically. So it's slightly different. And then does the same thing there. So that's the tile rendering. Yeah, for every scan line of a tile. Joy. Then you've got the merge. Draw and merge. So merge must be down here. There we go. Merge ULA screen. So this is basically copying from our ULA single scan line that we've just rendered into the final destination texture screen, and merging with whatever's been drawn already. So tile map behind, or if the sprites behind, anything like that's already been drawn, this is going to draw over the top. Now the only thing that's different here, because it just used to be black on top with the transparency, but we now deal with scrolling. So we've got X scrolling. So it's all byte per pixel now at this point. So we're really just taking the X and adding on the scroll, and also the clip left, and then looking for wraparounds and whatnot as well. So once we've added our position on, we then get into a loop for however big we're going to do it, and that's just the left minus the right minus left number of pixels, so that the left is less, the rest is left as the kind of global transparency color if it's been clipped, and then it just loops through. So it gets the color from the map, which is not quite byte per pixel. It's actually 9 bits. Remember. Thank you everybody who wanted that extra bit. And this was the stuff that I had to change because it was all bytes, and it just, as soon as they added that extra bit, the whole rendering stuff went out the window. So it gets the color, checks the global transparency. It only ever compares with 8 bits. It then looks up the color. So although on the next you equate those 9 bits with 3 bits RGB, they're not actually expanded into 24-bit colors. When we did that right at the start, the colors just didn't look the same as the next. Jim had a palette of colors that he used to actually do stuff. Let's see, we've got a, where have we gone? We do have something that actually, although I might have done that in the end, do you know that? No, it's the base colours. Here we go. The base colour. So red and blues weren't right. Base red and greens weren't right. Isn't that a blue one as well? So oh, okay, so it's just mixed. So what we do for the colours is using those base ones, those next colours, we've got these conversion things that actually provide proper colours. I don't know why it's RG. I think it should just be base colours these days. I think it used to have separate tables, but for each 1, 2, 3, 4, 5, 6, 7, 8. So your 0 to 7, red, green and blue, they don't map directly to just the straight bits. So if we do, you can see it's kind of, you know, offset. So that's clearly not 3 bits, it's slightly different. So that would have been 1 shift left. Was it 3 bits? So 4. Yeah, so that would have ended up with 1, 2, 3, 4, 5, 6, and 8. 1, 2, 3, 4, 5, 6, and 8. So that's what we would have ended up with if we just took our straight 3 bits of next colour. But actually, for a more convincing colour match to what comes out to the screen, it's actually this colour for that 1 bit, that first bit, which is totally different. 1, 2, 3, 4, 5, 6. Yeah. So Jim had worked out these matching things ages ago. So we never use those colours directly. When we're going through, I work out what the 512 colours are going to be, and that's basically using these base colours as a match, and then they get merged together and they go into the core. These are the next colours. So any colour you pick from the 512 colours that the next has, that's looked up in here as this is what the final PC colour is going to be. To output, and it's, again, it makes things a little bit more complicated. I used to do transparencies to these things and it was just it didn't work. So that's why I kind of went back to doing all the color conversion stuff. All the color merging and everything like that is done on next colors, and then just at the end I go, right, convert them into what's going to go in a texture, because it wasn't matching up properly. So we do all the rendering to the single scan line as next colors, and then right at the end when we're going to the texture, we go, right, look that color up, put it in memory. Well, that makes sense because it is faffy. And then we move the PC one across. So the PC one starts at the left column window and then starts moving across. But the source doesn't. It starts halfway along. Yeah, something like, yeah, basically. Each channel is the 3 bits, and then just right at the end we go, right, we're about to draw you, we'll take you over. So when we're doing the scroll, we just keep incrementing when it's bigger than the edge of the screen, so we've gone past the edge, then we do a wrap round. Because we're a memory pointer, we can't do that, and I can't allocate memory based on boundaries in C# without going to global allocs and stuff, and that's a pain in the arse. So we just keep track as a counter, and then we wrap round, and that does the wrapping for the scroll. So that gives us our ULA scroll. And that's the simplest one for merging. Oh dear. So layer 2. Merge bundle. So where's draw layer 2? Merge layer 2. Yeah, there's several layer 2s. Right, okay, so layer 2 drawing. So again, this was the first one I wrote. This was all it was. It was this in like 16 sprites. So it was just so easy. I think we had scrolling. Yeah, we did have scrolling for it. X and Y wraparound scrolling. So that was relatively easy. But again, layer 2 goes to a scratch. Works out the scan line it's going to do. The scrolling's done here because it's byte per pixel anyway. Yeah. Oh, transparency. So here we only fill up to the clip window rather than black the whole line. So it's a little bit faster. And then, yeah, and then it just loops around. Oh, it's got priority stuff. Yeah, The priority stuff's done in 8 bits, not 9 bits. And then it stores, because we're double pixels we're storing, it stores the 2 pixels of the colour. So it's pretty simple for a 256 colour screen. That's the easiest one, probably. And again, that's when it was simple, when it was a byte. So that's the 256 colour one. Then we've got the 320. Now 320 goes in columns, so it's different in the way it adds and moves. Fundamentally the same, but the memory is arranged in columns until we blat it in the line again. Then the loop is basically the same thing, but you can kind of see we take which one. Yeah. And then lastly, you've got the 641, which is nibbles in columns. So this is a bit more complicated, but same idea. And then depending on which one we're doing, you've got pixel 1, pixel 2, it draws it in the 2 pixels. Yeah, 16 colour ones. So it's broken into 2 parts. First pixel, second pixel. It has to look up the different colour for each one. Column render for the Y shift. Well, they can all scroll if that's what you mean. All the layer 2 stuff, all the high res, they're all X and Y scrollable using the hardware registers. They've all got kind of adjusts. So there's scrolling put into these things. I don't know if anything's done full 640 scroll yet, so this could be totally wrong. Yeah, 320 is vertical stored and 256 is horizontal. Basically, so because you're 256 high in the 320 mode, incrementing like the H register takes you to the next column, where in the 256 mode, incrementing H takes you down a row. It's to say if you're doing adding, you know, a 16-bit number, you can just increment, so it's quicker. It means rendering, you would render in columns and you would have the same speed as rendering a 256 one. It keeps it a bit simpler. So 640 is the same, it's rendered in columns. Yeah, you could do it for both as well. Although using the LDWS instruction, it kind of does it all in one go, it kind of moves down anyway, so it's not a problem. You could in theory do the Wolfie one instead of 256, but 320, I think that might be pushing it because I'm already struggling a bit with, you know, the speed of it, and that's 256 with it's actually 128, and then the middle pixels are all kind of fudged along a bit. So, however, 640 does the 2 pixels for 16 color. And then the draw layer 2 call will just check the mode and do whatever it needs to do. So that's rendering layer 2. Then you've got merge layer 2, which just kind of goes through again. The colors are all there, then it looks it up and stores it if it's not the global transparency. So it just kind of builds it up masked. The scrolling's all done inside the layer 2 stuff, so this is just a straight copy. This is the easiest one actually. It's the most straightforward. That's LEA, I've done tile map. So the big one, sprites. So we've now got 128 sprites. And they can be 16 color or they can be 256. And they can all flip and rotate and expand several times. So there's just, and you've got the relative stuff and for shapes and everything else, so you've got to keep track of what was before, so that you can, linking, so that you can then offset previous sprites from what was there before, and so it goes through all this shit for every sprite. It's just horrible. Oh dear, why did I do this? Yeah, bugs in sprite stuff is just a nightmare to find, because you got to go through all this shit. So you can see there's a while loop there for basically doing the linked offset stuff, where it's got to find sprites and then move to the next one and stuff. It's just horrible, and it does this for every sprite on every scan line. You see why rendering just takes so long. I think you can have 100 sprites per scan line now, so it's got to go through so much stuff. Yeah, no, it's just, oh, we'll just add this, could we just add the unified stuff. Yeah, scale flips and move the sprite. Yeah. I can't remember how half this stuff works. I figure it out for when I'm doing it and then promptly forget. Yeah. I'm biting the tongue again. So, jeez, unified. So yeah, it's got to go through all the different flips and scale for unified mode. I can't remember what all this shit does, but it's based on previous stuff or whatever. Yeah. And then once we've done all this, so there's a loop out here somewhere. Where's the loop? Oh, and we've got to black that line as well through the clip windows to be transparent. Although I hear now there's you can put sprites in front of or behind tiles as well now, which we don't have yet. So that would require checks in here as well to have two different line buffers, because Flash keeps asking me for that. Yeah, fecker. Alright, so yeah, it's got to do all this per sprite. Yeah, on a palette of it, so for each pixel that it draws, it will have to check to see which screen goes in front or behind. I hate you all. I really do. Oh dear. I can't see where my loop is. There's got to be a loop out here somewhere. Oh, that'll be it there. So that's my sprite loop. Yeah, something like that. Is that just for the tile maps in front and behind? Or in front and behind the tiles and ULA? Because you can put in front and behind the ULA, but I wasn't sure. I can't remember. Yeah, Flash keeps asking for it, but it's such a nightmare. So yeah, so that's the loop for each sprite, because you can flip the order of sprites to render front to back or back to front. So it loops through for every sprite doing all this, and then gets down to the render, and then oh, this is the size. Yeah, because you can scale up. Yeah. Yeah, if I ever get around to doing it, I will at some point, but it just crushes me thinking about it. So, yeah, so you've got to do all that, and then you come down and discover it's not, this sprite isn't on this scan line. So you've got to, because of all the relative stuff, you've got to figure out every position, every scale, everything that's done. You work out all that, every single scan line for every single sprite, and then the sprite could be above the scan line you're doing or below the scan line or something like that. I don't think it would matter at this point, to be honest, because it's done all this work anyway. So it has a position and size, and you just go, is it within this area? So it wouldn't have really mattered. So yeah, so once it's decided this sprite, however size, scale, rotate, flip, extended, linked, whatever, is actually being rendered on this scan line, then we'll have to go through and work out how to draw it. So you got to get this scaling delta. Yeah. So for every pixel, we add on a fraction so that we can kind of scale them up. And then we've got flips and rotates as well, but that's based on 16 by 16. Yeah, you need to keep them the same. You can't have two versions of the next. One being better, that would just be a nightmare. So there we go. So 16 pixel size. Yeah, so it's doing the scale stuff. 16:8 flips. Pixel size, yeah. And then works out the transparency. You got the 4-bit transparency, which is based on an index, not a color. Then you've got the scaling. So the counter is the fraction that we're working to, which are these. So that'll deal with the incrementing, moving along and stuff. So because it's not fractional, like scaling it is fixed sizes, we can at least just have a counter. Then we get I must look it up or something to simplify things, because I used to have it split. So then we get the color and store, blah, 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 blah. I mean, that's dependent on game, really, isn't it? The problem with more sprites is we need more shapes. And the shapes are in that BRAM, and there's not a lot of that. So I don't think we could have more. There's no point in having 1,000 sprites and 10 shapes. You'd need lots more shapes to make use of them. So anything more, really. I mean, even now with the sprites we've got, there's such a limited shape. Yeah, but there's no way to get the pattern memory because it's all in BRAM, and that's limited. So we're kind of stuck with what we've got. 120 sprites is stacks. Because you can multiplex them as well if you really wanted to. That parallax scroller thing I did, you know, with the 4 layers of 4 playfields or something, that's all sprites just being multiplexed. So now you get 100 sprites per scan line. 16, what's it? 16, 256. So you're going to be 16. So yeah, you could get 1,600 sprites if you really wanted to. That might be exaggeration. Maybe half that, 800, by the time you flip back and forward. So there's plenty of sprites. So where was I? Right, so that's finally rendering the pixels of a sprite. It's palette offset, gets the color, because sprites have offsets as well. Oh hell. And then looks the color up, and that's the final thing that goes in. I used to do the merging here, that all gets shifted out when I was doing the refactor. So you can see for every sprite out of the 128, so much code to run through, even if it's not drawing it. You know, even if you get all the way down and you go, oh, I'm not drawing this one, you've still executed so much code all the time. It's amazing it runs as fast. I'm going to say it again. It's just ridiculous. So that's sprite. So we're going to draw a scan line. We did that. So that's what all the individual parts do, and then based on the layering, you know, it'll kind of do that, and then we'll merge later on. The merge stuff is made it a lot slower because I used to draw straight to the screen, and it does make it a lot slower, but because of the front and behind pixel stuff that you get now, it's kind of a requirement to go to these buffers and then decide, okay, this is how I'm going to order them. Technically speaking, I could just draw everything and then go, right, now how we're going to merge them, which would make probably each, I could extract, like, you know, draw tile map, draw ULA, all this kind of stuff out to here, and then just have this stuff to decide how to merge. Because things like this, you know, you got the sprites there. Now what I don't know, so Jim, you might know this, if you can put a sprite behind the tile, but it's kind of like this and there's a layer 2 in between, does that mean the sprite would still go behind the tile? Because technically that means I would have to move the draw sprite up anyway, so that when it came to draw the tiles, I could merge sprites properly. It's just, it's like the 64 stuff, when you start doing sprites behind things and then you put another sprite in front, but the sprite that's rendered over the top is actually behind background, and you end up getting background color showing through other sprites because of the way it merges. It's just no, the 100 16 by 16s isn't guaranteed. It's 100 16 by 16, so it's not 100 sprites. Yeah, it's if you expand stuff to ×2, that's another 16 by 16. So it's, by the time you've expanded out, it just goes fucking hell. It just starts subtracting off. Yeah, I think I'd have to do a demo to try put sprites on top and ULA behind, then tiles behind, and then put sprites behind tiles, and then see what happens. It's just weirdness would happen, and emulating that might be a pain in the arse. Because certainly in these cases, I think I would have to move all the rendering outside to build up all the buffers, and then decide later how it's going to merge. I think that might be the next kind of refactor. So anyway, we've got the different modes. These all draw and merge in the different orders, and then there's the 2 special orders that are out of date now to do with blending, which we did have in, and then they changed it. I have no idea what it is now, but I'd have to go and change how the blend works, because I have no idea. Yeah, there's some weird multiply or stencil thing or something now. I don't know how it works. Oh, just summon a cheeseburger. I could do with that just now. Yeah, there is. I don't know where the merge has gone. Oh yeah, and then after that there's the draw layer 2 priority pixels, which goes in front of everything, which I'm not sure is the case anymore. It's layer 2 always, yeah, it is, isn't it? Layer 2 priority pixels always appear in front of everything. So you draw that, and then if there was any layer 2 pixels in front, they then get drawn on top. And then there's, yeah, here's the blending stuff as well. So again, it draws all that, and then depending on the mode, which these are the bits that are wrong. These have now changed and they'd rewritten. So it goes through and does weird blendy stuff, which I don't know how they now work. Yeah, I'm not too bad because all my rendering goes to separate separate buffers, and then I can merge them. So it's not too bad. I could change how it's done. Like I say, I could, in theory, basically take all the draws for that scan line, just go, right, do all the draws at the top, and then they would go to all their different span buffers. And then each of these would just be how they are merged. So it's not terrible. This kind of going to separate scan lines and just having separate span buffers and having them all with next colours, and then just at the end going like merge like this, merge like this, merge like this. Does have its advantages, although it does take a speed hit to do it. Yeah. So at some point I'll need to change how these are done once we know how they're fucking done. I have no idea. Yeah, we've got to have that. So if it's layer order 6 or 7 and we're doing the merge, then it does the merge, whatever those are going to be. Like I say, they're two different ways. I don't know what they are. They're funny. There's a lighten and there's a darken, but like I say, they've changed. I have no idea what they are now. So they need to be rewritten. Yeah. Does anybody use them at the moment, these merge stuff? Because initially they were getting used. I think Kev had a demo of them, which is how I managed to get them in the first place. But I don't think anybody's actually using them just now. So yeah, it was to do that kind of semi-transparency stuff, which is nice, but right. So I have no idea how it works though, the actual maths behind it. I think Jim had told me first, if you look at the this one, it's got a weird blendy thing, and how it all merges together. So right, okay. So each time a scanline's rendered, it has to come through this, do all this stuff, all those tile background renders, layer renders, merge them all together, which involves taking these multiple spans of next 9-bit colours and converting them to full colours, and then if it's not global transparency, blatten it into a final destination. Taking it to kind of all the clip windows and all that kind of crap as well. And like I say, tile maps and everything, they all have to flip, rotate, do their thing. Is that one? Yeah, that just kind of calls up. And I think that's about it. I mean, what's that, almost 3 hours, jeez. That's the kind of rendering. So the rendering, as you can see, it goes through, yeah, something like that. I don't know. We'll wait. Like I said, we'll wait until it's finalised, because I don't trust it at the moment. I'm not going to write it again and again. So we'll wait until it's actually, yeah, this is definitely when it's going to be done. That's the sample stuff. Basically goes and gets another byte sample bit to put in. Yeah, definitely. I think it would just make sense. So the other stuff that we've got is plugin stuff. So you get exposed a bit to the plugin in terms of the interface and how it works. So when you write a plugin, you can do all these commands and they go into CSpect and get stuff out. I did add a couple more recently, which colours, because it was you could monitor the colour palettes and do it all yourself, but it's just a pain. So you can now get a value from the colour palette, and also get those fixed 512 colours that I translate to. Yeah, finally plugins. So I use this now in the next registers when it's a transparency colour, that global transparency thing. Oops. So which is 14. So here, this colour here I use, I get the next register that's been set, because I monitor all those, and then I look that up in the colour palette to see what it's actually going to be in the next colour palette, and then I use that as a lookup into the actual colours. So if we go to, where the hell is that? Next register. So this one will be open source anyway. It'll go up on the GitHub repository. And I'm hoping this works on Unix and stuff. It's using the same stuff as the other thing, the copper disassembler. So with any luck it will render. Although I don't know about the tooltips. That might be another thing. It's not really draw disassembly, is it? It's because I copied the copper one. And then we've got the tooltip. So what we do is we've got the register, and we've got track of the registers because I monitor all the writes. So when we're doing a plugin, we initialize. So that's the initial part. We get passed in the CSpect interface that we just keep. I get the global window handle just for using for stuff. And then this is how we register different things. So this is registering a key press. So when this key's pressed, we'll get a callback in the I/O stuff. We then go and register for whenever a next register is written. So we ask for all the next registers. When a key's pressed, it calls into here. If it's the one that we asked for, which is this ID, then we can activate our form. We don't actually have a read, but we've got to fill in the thing. We'll get to the tick in a minute. So on write, if it's a next register, well, there's only a next register. I could check the ID to see, but we're only asking for next ones. So if it's different to what's there already, then we write it and then we set that counter, because it stays green for a little while, then goes back. So we can put in a counter, and then we tell it to invalidate. We also monitor the clip ports so that we kind of get the cycling in the clip windows correct. So it'd be tough to do this for the colors as well if I did put in, and they're more complicated. At least the clip windows just kind of increment loop, and then there's another register to reset them. So they're pretty easy. So whenever you write to the clip, we keep track of them in a little clip array so we can display them in the registers, which makes life simple. But that's basically every time the next writes to a Z80 register, comes in here, we store it so that we can display it in the plugin. So we look it up for writing. This is a tooltip item, so I have a list of all extra things you want to draw in the tooltip. So it'll draw the text, Windows will draw the text, and then we can draw things over the top like that little box. So we could put images and stuff in there if we want. At the moment I've only got the colour box being done. There's a width and height and there's a colour, and then it's a full RGB one there, so that gets looked up. So we look at here. So this is doing the transparency. I get the 32-bit colour, so that's the final, that 512 array of colours. And I look that up so that the value that's in the next is, that register is an 8-bit register. So we shift at 1, we look it up, and then we can set that as our draw colour. And then I've just got an offset in width and height to kind of fix and draw the thing in. Then that gets added to our items to actually draw when the tooltip appears. And that's the only really complicated one. The other ones are all just text formatting. So we go up, so there's the ULA control, clip ULA control. It's just a string format. This is just a bit of padding to put on the end of the line, because it was right up against the text. That was annoying. So it's kind of that and a new line at the end. So I just add that on to the end of everything, and it does my new line and stuff. And it's all just formatting and then printing up stuff. So again, we just get the values out, and then we just check to see what it is and set the text based on that. And that's the same for all of them. There's the clip registers, like that. Different clip windows. The different cores. Peripheral 1 settings, so you can see the joystick mode. These could be bugged to fuck as well. Excuse my language. I was trying ever so hard not to swear in this. Oh dear. But it means you can have a look and see what the joystick type you've set, assuming it's all set up right. I've tried to do it right, but I'm not writing test programs to go and go, yeah, that one's set fine. CPU speeds, global transparency, sprite and layer system, so it'll show you the proper layering. That came from the registers, the document, so this is probably right, I just don't know what it does. And then it prints these things up. So that's what this one is doing. I do intend to do a sprite viewer as well. Basically along the same vein. I know what it does and you don't want to know. Okay. So this is the sample one that goes in. So this is tagging into some read writes on the port. I think I was just doing a clock port simulator thing. But it doesn't actually do anything. Tick. So you saw in the main loop, every time it does a main loop, so doing a frame, you will get called to tick. That lets you refresh stuff. So in the next register one, oh, it's not that one, sorry, it's this one. And tick, we run through all the registers, we see what's written and whether we need to invalidate anything to redraw. So if nothing's changing, then we don't have to render anything, so it keeps the speed up a little bit, because it does slow down a bit. So oh, there is the GitHub repository that I put up that's all kind of open source, so anything goes up, anything that's a plugin will go into there. The DZOG plugin is now in that as well. He was getting annoyed having to rebuild it every time there's another one out there, so I've taken over the building of it, and every time the plugin's done, it gets updated, obviously, because I just build it along with everything else. I mean, really, it's just going through the sprite shapes and printing them so folk can see what they are. It would be nice if other people did plugins. That was the whole idea. Not many people have. But they are super powerful. Oh, serial port, I forgot all about that, and the networking. Jeez. There's obviously the Wi-Fi on the next as well that I've even looked at. So we've got the UART stuff, which goes into the serial. It's the one that pretends to be the socket. Can't remember how it's serial port UART. I'm sure it was just the UART. Yeah. So that's the Wi-Fi module. Totally forgot about that. I need to know what it's supposed to do, because it'll obviously fail the L2Mix stuff. So I need to know what it's supposed to do and if it's going to change. If it's going to change, I'm not touching it. Hi, thank you very much. Yeah, but I mean, not everybody uses the DZOG stuff, so it's. I need something that's part of the plugin stuff here. So I need one that's part and parcel that will, folk can use in CSpect if they're doing. Even if somebody's not doing dev, if they want to hack stuff, you want people to go in, see the spikes, copy paste, save them out or whatever, like the old action replays in the 64 used to do. That was just invaluable, being able to do that, dump memory, save sprites, all that kind of stuff. I want to be able to do all that. This stuff here is the Wi-Fi module, or pretends to be the Wi-Fi module. If you have hardware plugged in, then it will just use the actual .NET serial port and just send stuff to it. So it's quite dumb. Otherwise, we use a TCP stack and we pretend. So all these commands that you send then get sent to the TCP modules so that we can fake up things and pretend. So when you write stuff, it kind of goes to buffers and sends things, so that you can kind of get some kind of Wi-Fi under emulation. You can obviously plug a Wi-Fi module in as a USB thing, but if you don't have that, then you still get a little bit. This would be another one to maybe move into a plugin. You have to take over the port. You might be able to do it. It goes through this the UR interface. But you might just be able to do it through the next ports instead of that. I'm not sure. Yeah. So yeah, there's the C#'s internet thing. It does all the packets. So yeah, that kind of fakes stuff up. I think that's everything. Is there anything anybody particularly wants to see that hasn't been shown? I said at some point I'll do a debugger. You want to do a clone on the next, or just a general like PC clone? I was going to show this. So this is the other side of that interface. Whenever you call through that interface, it calls these things and just goes straight and gets values. Oops, daisy, that's not what I wanted. That's the debugger interface. It kind of does all the debug stuff, so you can do a full. That's how DZOG does it. He calls all these things, so you get full debugger control through the plugin interface. So it's perfectly possible to do a thing. C64 clone to run on the PC. Well, Spectrum version to run on the PC, I'm assuming you mean. It's a Spectrum is the proper one. If you're doing a PC 2D game, Game Maker's plenty. It's great at doing 2D stuff. It's much easier than most other things you'll try to do, especially for that kind of game. Sprite access, it returns the sprite stuff. So it all just interfaces directly into CSpect's stuff, so you get direct access. And there is a whole lot of globals. I can't return the global class, but there's all these commands you can ask for things. And as people want more, they can get passed in. So I added in these 3 new ones for this one to fix that bug of the next stuff opening. So there's gets and sets for all these kind of things. Yeah, so you can go through and set stuff. Although some of them won't let you do it. You can just ask. How are plugins loaded? That's a good question, Mike. I'm glad you asked. So plugins kind of gets a path, goes through and looks for all the DLLs. It then tries to load them as an assembly. Which is basically trying to get it into its current app domain. And that's a whole load of magic stuff to basically see if it's a DOS tether and a whole load of shenanigans. At the end of the day, once it's decided it is, it'll try to load as reflection only, so that's the full path that it's going to be coming in. And then it will loop through that assembly, just say reflection load only, for the types that we're interested in, which is the plugin. So loop through all the types in that assembly, gets the interfaces, loops through them. There's many types in the assembly, and then there's many interfaces in those types, so you loop. If we find that plugin is part of that assembly, then we can say we found one. False, we don't bother. If it is, then we do a full load on that assembly. We then scan the assembly for all the types. We enumerate them all the packages, and there could be many assemblies. So here, these are all single assemblies with single types in them, but I could do multiple. All these things could be in one assembly. So you want to find all the packages within that assembly and look through them, and then you create an instance. So that's basically newing that class of the assembly that's implementing that interface. We new a new C# interface, and then we call that loaded package with that callback. And I thought I saved it there. Package. Now return that, because we keep track of. Oh no, because that's on. Yeah, it returns a list. Oops, daisy. So it returns that. All right, so this is a single plugin. Okay, so when we new a plugin, it got that a plugin will have the assembly, and it once you've called it and created it, it will have a list of those I/O ports that you've kind of done. So that's coming from scan assembly. At this point, what's this? Plugin. Yeah, plugin. So something, so that's plugin manager. Hang on, I've lost myself again. Yeah, so it creates a new plugin, loads the assembly via that plugin. Once we've got that, that's a list of all the plugins that we've loaded. And then it does the add IO requests, which goes through all the plugins and gets the IO. And then depending on the type, so write, read, all the different types of IO requests, it will add them into the port, into the array that that's going into. So it reads that. If that's not got any plugins in it at that slot, so if you look at memory, hang on, I'll come back to your topic in a second. Port write, port read, address write. So you look at the address write. So there is 64k of these arrays, an array of 64, but they're all nulls inside. So it looks up the address and turns out, so that could return null. If nothing's written there before, it'll make a new list and add that into there, and then add us to that list. It will then do a sort, because I think there is a priority system in there. That might just be to keep it consistent, because they could be loading from different orders, so it just kind of keeps it a bit consistent. So basically there's an array 64,000, most of that entries are nulls, but wherever there's a memory access, there's going to be a list of stuff, which could just be one or it could be many. And that kind of goes into all those different ones. So when it's trying to execute memory, or it's trying to press a key, next register, read writes, ports, they all kind of go in. And that loops through all the plugins doing all that. So like I say, there can be stuff that has multiple plugin requests in it, and then the first one that deals with it is the one that gets it. And really that priority is the one that would get there first. So if you need to be first and you're not going to do anything and pass it on, then you can do that, is the idea. Yeah, I think. Sort keys. Oh yeah, yeah. When you do keys, these things all have to be in order, so that when as a key press and I build up the string, I build it up in the same order as these. That means the plugin doesn't have to worry about putting control before alt or anything else. I just resort them all. And that's it, really. So, like I say, plugins, it scans it, it loads the assembly as a reflection only, it then looks for all the interfaces. If it's an interface we're interested in, it will create a new plugin and then load the assembly properly. And then at the end it will go and add all those IO requests that it got back from the plugin initialization to do whatever it needed to do. In theory, I could add different types of interfaces for something that's not in the CSpect stuff. I could have done a memory interface, an IO port interface or something, but I like having the one interface and then you could call and do different things. But you can do multiple interface types that you look for if you really wanted to. I'm very fond of C#'s reflection and making plugins. Just about everything should be a plugin if you can possibly get away with it. Have you ever used Dreams by Molecule? No, sorry, I never used that. You can do 60 frames per second. There's a minus, what's the command line? Flash wanted it, didn't he? Yeah, minus 60 on the command line will give you a 60 frames per second version and all the timings of. Yeah, in theory minus 60 and VSync will make it smoother, but there is a weird Windows thing. It's messy in places, but yeah, as long as you keep things small, it's not too bad. It's when you get these massive functions. It's like the sprite function, to be honest. The sprite one's horrendous. I hate it. But because it's this huge loop that has to do, if you start doing lots of calls, it will just slow down. And it'll be painful as hell. So, I mean, this is one of the worst functions in the whole thing, because it just goes on and on and on and on and on. It's just horrible. Really, these should all be little functions. Go and work this out, go and work that out. But because of the nature of it, you're doing so many, you're calling it so often, it would cripple. And you'd have to return a whole load of this stuff back. It'd just be horrendous. Oh. Yeah. For the most part, it kind of does its thing and kind of plods on to the next one. It is reasonably modular, but like I say, the rendering is just an embarrassment. It's horrible, but it's the nature of the next, the way it's done. If I could think of a better way of doing it, I would, but you know, it used to all be in this function, and then when it started getting all those layers, it kind of all moved out into that kind of separate draw. And that's kind of like, yeah, default colours, fallback colour. And I hate all these loops I've got to do just to fill in things. It burns time. Oh, drives me nuts. There's so many. Okay, go and fill this in. Go and fill this in. Like I said, I think ideally I would move. I might move all these kind of draws up because there's no reason to have them in this order. It's the merging that's important, not the drawing. I think there is a layer 2 draw front, draw back or something. No, it's maybe been split now. It used to have 2 different draws. I think now it just goes to the 2 buffers, and it keeps it a bit simpler. But even that, it's just, I hate having the 2 buffers. It's horrible. So left, right, fill. Yeah. Yeah, the priority buffer, and I just hate it. But I can't really think of another way of doing it. But it makes the drawing just so painful. Because you're having to continually fill that stuff and then draw over the top of it, and then when it comes to merge, you need to have that separation. Because like I say, I used to draw straight to the screen, so I didn't need to keep filling. It would just draw on, and it would deal with all the scrollings within there. But when we start adding scrolling to everything, and then all the clip windows and everything else, and doing the scrolling and moving and clip, it was a nightmare, absolute nightmare. So, okay, see you later, Jim. Yeah. So, there's SD cards and SpecT. Oh, yeah. I think we've been through everything. There is one other thing that I'm wanting to do that I've not got around to. It's quite complicated. I've done an interface for doing the SD card stuff. I know it goes through the SD image, and that deals with these commands and reading the buffers and all that kind of stuff. I would like to at some point do an SD card simulator. The idea behind that is you basically point to a folder, and I do a mock-up SD card in memory, so that you could have all your next files on disk, and you don't actually have to have an image and put images and copy files onto the image and extract them and all that kind of stuff. It could all just be files on disk, and it would all go through a fake SD card, and that does imply making boot folders and structures and FATs and everything, but I mean, it would be so useful just to be able to go, okay, there's the entire next card directory structure there, just point to that, and then behind the scenes there's this kind of fake disk image that's kind of maintained, and then as you read and write folders, it just, you know, rebuilds this disk or whatever, so that it can you never have to have that image. It means you never have to, well, I need to copy loads of files to this disk image to have the next OS load it and all that kind of stuff. But it is very complicated, because you do have to maintain FATs and clusters and disk partitions and all that kind of stuff on the fly. But it is still something I'd quite fancy doing. So yeah, so I started doing it in this, but it's been shelved. It will take some time to do that. So yeah, so I don't think there's anything else. We've got the colour palettes, which I don't really go into, is just the next colours that deals with the 8-bit and 16-bit stuff. So it's up here somewhere. Oh, it's keyboard pressing and stuff. We've got that basic key stuff, you know, where we put in the basic keys where it tries to recognise combos, and it just looks at different keys that are down and then sends them to the next hardware, just puts them down so that, you know, you could do bracket, and bracket will come up on the next, to make basic programming easier. think it works. There was a weird issue with it doing key repeats and stuff, but I think that's been fixed. So it's got a whole load of stuff to do for all that stuff, which is nice. Cursor's just going on and off. Yeah, process multi-keys. So there's a whole heap of stuff to do with that. Basic key up and down shenanigans. And you press keys and stuff. If you're in a debugger, calls, do resets, loads. I mean, it's just key stuff. There's not that much to it. That was for the glow stuff. Was for the shader. To get TV mode, you can change a whole lot of settings. But I mean, in debugger, just all the debug keys. Yeah. It's just passing the keys into the normal keyboard, pretending which keys it is. If you ever do a Spectrum emulator, it's incredibly simple because you're basically just doing a Z80 processor, start it up and let it run and do its thing, and then you just have to get these keys passed in onto the port. So whenever they do a port read and write, you just have to return bits based on the keyboard set, and that lets you type. And then you just draw the screen from 4000 to 6000 or whatever it is to display it, and that's kind of a Spectrum emulator. It's so simple to get running. I did think about doing a stream where I write a Spectrum emulator because they're really easy. Find some core that just works. So I'll check plugins. So that's the key presses again. We get the keys and we check to see if there's any keyboard plugins. We build up the key string whenever you type, look it up. If there's any one, we pass it off and then it can open up and do things. There's the palettes, that's what I was getting to. So the colouring stuff is just picking the palette and putting the colour in the right palette. This used to be a lot more complicated. We also work out the kind of 32-bit colour. I don't know if we actually use that anymore. No. I used to put 32-bit colour stuff in here for when all the drawing before I always went through that lookup colour at the end in the merge. I worked out when you set a colour what the 32-bit colour was, and I drew with that. But now it's much simpler. I don't use any of this stuff really. I just get the colour, I store it in the palette, and it's all merged later on. It makes life much simpler, but it does take that speed hit. Palette selected. The 8 and 9-bit stuff really is just a bollock. It just complicated my life so much. Just the different sprite palettes. I mean, all that stuff is nothing much. Yeah, I was trying to rationalise a lot of my stuff. Don't need that anymore. I'm just going to take that out while I've got a chance. There you go. Yeah, escape, shut down. These aren't used anymore either. That's all been offset into the plugin. So I don't really need that now. Yeah, all these things are not used anymore. I need to go through and start just cleaning up. There's so much stuff that's just, it's 5 years worth of shuffling code about as hardware changed. Yeah, it's nice having the DMA and copper as a separate thing that just acts on its own and it doesn't really have to worry about it. It just kind of runs through and does its thing. It's quite nice. And once you've got everything set up, things like the DMA where it just increments based on increment and decrements, it's source and destination addresses based on what's been set, it's fine. It just reads a byte, increments, stores a byte wherever your port or whatever, and the memory in port is just, it's like a peek or poke, basically. Where's it gone? There you go. So out B or poke, and then there's an in B or peek, so it just uses the memory system that's there and maps in. Yeah, 5 years on the fucking thing. It's just sworn again. Maybe swear again. Bugger. Yeah. I didn't put a date when I started this one, did I? No. Yeah, I don't know. So, is there anything else anybody wants to see on this since we're going through? That's, you know, ROM image. Got the globals. It's all the different tile map stuff, 16 color stuff, and it's our memory. It's just a straight array. Oh, it's 4 megs. With the top part that's something else. In my unicycle act, yes. In my spare time. Don't show you though. You'd be too excited. There's nothing really extra. We've got the actual OpenTK interface is just OpenTK and you know, OpenGL. So I mean, it's just, that's how I would draw stuff. Just draw code. It's, you know, it's straight. Just, you know, draw, build a vertex thing, and draw it. It's very simple. It comes with a kind of game window that you've got to kind of tag into. That's where all the keys come from. And then they get passed down to the main program. But that gives us our cross-platform. I do tend to go through an interface rather than a class if I can possibly do it. That means you can swap things out. So you find the main loop uses an iRender interface rather than the render class. It's always better to use a thing if you want. It was 4 meg. There was a reason early on that was that. Again, it's changed so much since. So. There's no chance of it coming out as is on a Switch because Nintendo didn't let you download stuff to it. There is a remote possibility if somebody wanted to release a game on Switch that we could do it, because then it's a bundle. So if, you know, Matthew Smith says, I want to do a Manic Miner on it that's next enhanced for some bizarre reason, or Flash Rooney's Warhawk thing, we want to do that on Switch, that's possible. We could do it. But on its own, so you could just have a load of Spectrum games on there, no, there's no chance. They wouldn't let that pass. They don't let things download. So we had that at Game Maker, but they weren't letting us download anything to it, so we couldn't put Game Maker on it. So, which was a shame. We could have put the runner on it and downloaded our content to it so that they could do stuff. There's also weird issues that you wouldn't think of in that with SD cards, there is actually a license you've got to pay if you're going to let people put media on it. So if it's not just text files or something, if somebody might put on a video or MP3, then you have to pay a license to let them do that. And Nintendo don't do that. When you make a game and put an MP3 on, then you will pay as part of the cost to Nintendo, you pay that. But for an end user, if you let them put on MP3 files or whatever for a player that did it, they would have to, for every Switch sold, they have to pay this MP3 cost per SD card. It's not quite an MP3, but it's this media thing that comes with every SD card. And they don't do it, so that was another reason we weren't allowed to do it, because people would download content that they hadn't paid for on the SD card. It's bizarre. I had no idea that when people made SD cards, they had this extra cost that was hidden, that they could kind of opt out of if things weren't going on there. So it's weird. I don't know if it's flash memory or SD cards. It's like that VCR thing. As soon as you get into that, then there's a cost associated with it. It's anything. It's not just MP3. It's it's any media where they could copy something. Then they've got to pay this cost that's supposed to offset the cost to creative people that make this content that you might have pirated. It's bizarre, and I'd never heard of it until then. It's really strange. So yeah, again, no chance of one, but somebody wants to do a game that they've released on it, is a remote possibility that we could. So yeah. So I think times that 4. I think that the next thing I'm probably going to do is, I don't know how it works. Yeah, I've not an idea, not a clue. So I've probably done as much as I'm going to do on this, and hope that other people extend it. It's fine and it's useful, and I'll add to it as I look over and say, "Oh, I really need to know what that register is." But it'd be easy when you're tying it to that though, because you would run it based off the audio that's 60 hertz, and then just buffer it with that. You would tie it a lot tighter if you were doing it on a console. PC stuff there's so much of the OS stuff gets in the way that causes hiccups. It's crap. To do perfectly smooth, I mean, your LCD panel's still not going to be totally in sync with the audio. I don't know. I'd have to look and see. But yeah. Well, I mean, I did get some stuff running on Switch. And I have finally gotten access to the mono game for Switch that I haven't used yet. It seems a wee bit funny to put together, and I have got most of it transferred over to mono game without audio and gamepads and all that kind of stuff. But it does run like the Beast demo does kind of run in it, so it would be possible to do. But again, that'd be a big investment to get up. I'd probably need a couple of folk that are wanting to do it. I don't know if one game would make it cost effective, because you'd obviously have to split the costs on it and the profits on it. It would get interesting, but it's definitely possible. If there was a demand. Like I say, I've got all of this running in mono game without audio and without gamepads, so it is technically possible. And you'd have to strip out things like all the debugger and all that kind of stuff. You'd strip out anyway. So plug-in stuff you would strip out. That would give you a bit of a speed up. A lot of the stuff that's got the ifs and buts in it, you could strip, because you're just going straight into effectively a next load. Yeah, it'd be interesting. It would take a bit of time, but it's certainly possible. My next dev kit's been sitting on my shelf for ages, and I had a chance to really play with it properly. It's a lovely machine. So you can see there as it changes, it does kind of stutter and stuff as Windows, but it's not the update, because the counter's going and it's quite happy. It's just the kind of mouse moves. It doesn't like it. It's weird. So anyway, like I say, this will go up as a plugin that folk can fix and update and add stuff, and then hopefully we'll get the whole thing so it's more like this, which would be really useful for folk, instead of kind of trying to guess from these things what the hell's going on. It'd be super useful. and I do want to do a sprite viewer plugin, particularly because I've now added the colours. I can decode them all properly as well and get the right colours up. Well, kind of colours. If a 16 colour, they're still going to be crap, but you'd be able to kind of select them or something, I guess, to get a better idea. Yeah. I did the copper disassembler, did we? So, copper disassembler is the same as the next register one. It's got the 2 keys. Oh, I forgot, it's got that mode as well that we don't really use. It's got copper IRQ visualizer. Hang on, what key is it? S. There you go. So whenever there's a colour change or something, it can flag where it is, which is useful. I think that's an RQ one down there. So if you've not used the copper one, it's quite handy. That's not been written to, this stuff. Yeah, if there's a few folk, it makes it more worthwhile. It would have to be published through my company, that's the only thing. I kind of make it and package it and bundle it and publish it. But that would all have to be discussed anyway. So anyway, copper stuff, it's really handy. Move weights. It would be nice to have the tooltips over these as well to see what the registers are. That would be really cool. Because there we kind of know it's the horizontal scroll because of that, but that'll be the significant bit, presumably. 47, 48. You know when it gets to 256. 1, yeah. And then stop. So, but it'd be nice to have the hover to go, that's this register and it displays, it's doing this. That'd be really cool. And you can obviously, with the plugins, you can have them all open at once. So 48 would be, yeah, there you go. Interestingly, that's not updating itself. You have to move it to update. I have to change that. Yeah. I'm not sure if the tooltip stuff's what's slowing it down when you do this. You know, having to create it if it's really painful, in which case updating doesn't make any sense. It's obviously moving, so when you move it, it kind of recreates it anyway. Although, yeah, I mean, that's when it is slow. I don't know. Yeah, but I do like that one. That's handy. And that'll work. It's not just beast. That's just, you know, analyzes the copper, and whenever a color change happens, in fact, is that colour change or is it just a copper write? It might be. It'll probably be set in the flag. Key press 1, global, copper weight, copper RQ. Oh, it's for copper weight. Ah, okay. So there's 2 different settings there. There's when an RQ happens, it'll set a line, and when there's a copper weight, it'll set a line. So I'll show you where they are. So if there's loads of copper weights going on the screen, they could just turn blue. But if you've got these kind of splits, it'll show you where they are, and it's kind of useful for like the beast to see where all the different raster splits are happening. Here you can kind of see, yeah, I mean, it could just be like that solid if there's loads of them. But here you can see where the split screens are for the different scrolls and colour bars. So these ones are for colour changes, and for scrolls, one there, and there'll be another couple down here. So It's quite handy. Yeah. Okay. No other. I think we'll put off the Retina plugin for another day. But we'll definitely do plugin dev on this, I think, if people are interested in that. Is there any other questions for this, or are we going to call it a day? So I just wait. Don't really have. Been 3 hours 37 minutes, Mr. Humbug. Yeah. I mean, there's several plugin examples now. It is pretty simple to just get going. And that, if you want to start one, this I2C thing is a good framework to start with, because it doesn't actually do anything. You know, get some reads and writes. That kind of comes in with these things. There's an ID now that, you know, depending on what the ID is, you can decide that ties into these things. Yeah, I think we'll do a plugin one next. Don't know when. Just whatever one I've got installed. What am I using just now? 17 I'm using just now. Yeah, you'll not get this one. I think they're on to 19 and maybe even 20. They should all just load and build. I don't think there's anything different in them. I do have 19 installed as well, but I haven't tried building anything on them. This is just the one I keep clicking because in the history it saves me looking for it. Like I said, there should be very little that you can't do in a plugin in terms of the hardware, because it comes in as priority. Yeah, there you go. Geez, I'm on 2022 now. Bloody hell! I should really upgrade. Because you've got that opportunity to go, I took care of this one, then you can kind of take over CSpect's behavior and loads of stuff. And I would love to do a debugger in there. You know, have a full debugger, external debugger from the actual program. Then folk could start doing proper Windows forum stuff for listings and all that kind of stuff, and viewers and whatnot. It would make life quite interesting. I also want to do a profiler. But I've got a feeling a profiler might be better internally, because of the profiler would really be as it accesses memory. You've got to increment counters, and you don't want to have to do plugins to call back for every memory access. That would hurt, I think. So while you could do it, you know, it would hurt. You could have an on. Well, no, see, you can't even do an on-off with it, because you'd have to register the plugin, call into it, and then say, oh, I'm not going to do that, so the call would still be there. So you kind of want that to be the counters internal, and it might be we do that as, you know, we do all the counters internal, but then we do some CSpec interface to reset and get and all that kind of stuff, so that way the slow bit is internal. Yeah, that'll probably work, because I think being able to see what read and write, spike and all that, and code runs and stuff, it is super useful, but I wouldn't want to draw that inside the debugger in CSpect. I want that to be an external. But yeah, the more I'm thinking about it now, the more having just the incrementing counters inside CSpect, and then having part of the interface to get those counters, then you can do whatever you want, and an interface would be much easier. Yeah, I'll maybe do that as a first pass, because that would be useful, just to see where all the memory spikes are. And what's running most and all that kind of crap. Yes. As long as you increment memory, a memory counter. This memory has been accessed, increment. This memory has been executed, increment, store, read, write, all that kind of stuff. Then an increment's not going to take up much of a hit. And you can just fetch them from a profiler interface. Yeah, let's do that. That'd be fine. Yeah. Okay, right. Well, I'm going to call it there then, if nobody's got anything they want to see. And then we'll maybe do a plugin stream another day. But I might start doing that profiler one. That would be good. I need to do a stream that's easy to walk through, because really you want a stream tutorial on plugins rather than just me working away on a plugin. So I'd have to come up with something simple that we could kind of show. I'll think about that as well. I think a tutorial plugin tutorial stream is what you're actually wanting. Yeah. Yeah. Okay. Right. I shall see you all later. Thanks for joining me. See you later. Bye.